All right, let's see if this works. Uh-huh. Says you're live. Excellent. Excellent.
Oh, yes. And now I'm seeing an advert. Skip ad.
Got an advert? Well, that's no good. Got to stop that.
What's that?
Adverts.
I don't know that you can.
No, I clicked the monetize button on the stream is what happened. The minute you do that, it'll throw adverts in it.
I was going to say.
But it'll just do one. It won't knock you off again.
No, I'm not adverse to seeing an advert at the start. As long as you can skip it when it gets a little bit in. It's once I got a 12-minute unskippable advert come up.
Really? Wow.
Yes, really.
12 seconds?
12 minutes.
12 minutes?
Yes.
Jesus.
That's uncalled for.
Yeah.
Yeah.
That is completely ridiculous.
I think I once had a 30-minute ad come up that had a skip button, but I missed clicking it because I was away from the screen. And just as I just missed clicking it, and then you had to watch the whole thing.
Well, I was watching a flat Earth video, either flat Earth or can't remember what it was, but it's one of those that has a lot of trolls. And to solve that, they had a subscriber only mode on for 2 months.
Oh, goodness.
Yeah.
Yeah, let's see if I can get some other stuff going here. Need to shut that off. I'm getting adverts. I'm on the damn channel. Stop it. Now that's uncalled for. Apparently it doesn't know it's me that's looking at it, so.
Oh, you're not logged in.
Let's see, I'll fix that like that. And go back to this, nope, thing over here. Here we go. Yeah, so I don't know if I don't know if you guys paid attention, but I put a video out over the weekend.
Been really busy, so I haven't had a chance to watch it yet.
I didn't think I got it. Did I get an alert for that?
I don't know. How could I tell?
Well, you're smarter than me.
But yeah, I did the.
You should know.
I did the video I've been threatening to do for a long time.
Oh, reciprocal zenith angles?
Yeah.
Yeah, I think I saw that.
Yeah, it's not long. It's about 16 minutes. Pretty simple. I used a bunch of data that got collected by Larry Scott and Jesse Kozlowski.
Oh, cool.
They took reciprocal zenith angle measurements between the Hagerstown Airport in Maryland and a thing called, what is that, High Rock Lookout or something like that. About 11 miles to the east of the airport area. And Jesse set up on the top of that rock, which is, I think, 1,100 feet or so elevation-wise above the elevation of the airport itself. And Larry was down on the airport. And lo and behold, over 11 miles, they measured about 8 arc minutes of divergence in the zenith angles, or the zeniths. Pretty much what you expect. If you take refraction into account, of course, it is exactly what you expect. And of course, the bevtards have gone crazy all afternoon going through that video. And as usual, they have no clue what the hell they're talking about. So Rumpus was over there trying to take them on. He actually went in Bev's Discord, and Bev's got got Rumpus's volume turned down to the point that he's not audible in YouTube. I probably could have heard him if I had turned the volume wide open on my audio panel. But then, if anybody else said anything, it was going to blow my eardrums out. So Bev knows what he's doing. He's just being an asshole. I don't know what it is about that they can't understand. Let's see if I can find... Well, first let me look at something here. I'll see if I can share something that you guys can see. Yeah. Yeah, there should be a oops. That's my video and it's running right now. Hang on a second. Let's see, but put that on pause. And I may have to resize things here. Yeah. You guys bear with me. I'm messing with...
You're messing with technical stuff, aren't you, Blue?
Yes, I am.
and it's fighting back, isn't it? Like usual.
And doing a damn poor job of it, too, I might add. So let's see. That's not the one I want. What do I want? We'll figure this out come hell or high water. I guarantee you. There's a way to do it.
Can you shrink the video down just a little bit? It's not the right side of it being cut off on the YouTube.
That's what I'm working on, Sean.
Okay. Okay. Sorry. Just trying to help.
Yeah, I know. Yeah.
Blue, you're not the only one having technical difficulties with their computer at the minute.
Oh, good grief. I don't know why this thing's doing what it's doing.
I think my fancy trackball mouse needs replacing. Because the left mouse button has decided that it doesn't really want to be a button anymore. More like a random clicky thing.
Oh, there we go. I think I got it now. Let's see. I want to do something else though. I want to move Discord back over on the other screen. Like that. And there's the rumpus.
Hey, Blue. Can you hear me?
Yeah.
Oh, jolly good. Unlike on Bev's, where you could just about make me out as a whisper in the background. Like, I mean, honestly, what a guy.
That's what we were just talking about that.
I mean,
Yeah, he had you turned down to the point I could barely hear you on YouTube.
Yeah, I checked it as well, and I could barely hear myself either, unless you boosted the volume. It was like a very quiet whisper at best. And the reason, of course, that the other people thought I was loud is because he turned me down for him. And of course, he's recording his input. So they all think I'm in the chat. They think I'm all a reasonable volume. But of course, to YouTube and to Bev, I'm incredibly quiet.
That's right.
Yeah. What a git. I mean, honestly, he talks about wanting debate and input and things, but he doesn't. And I wasn't even going there. Well, I was going to be, I suppose, moderately aggressive, but I was just trying to explain stuff to him. I mean, I've been meaning to watch that video you did. Was it a couple of days ago? Just hadn't got round to it. And I presumed it repeated what you'd done about you did a similar video about the difference in the elevation due to the bulge. Not different. It's not. That's the trouble. You see, the trouble is when you're trying to type in comments in 200 letters, you can't really fit in all the things at elevation. We all know, and it's defined as being above the equipotential surface, and of course that's not a constant distance from the centre of the Earth, even though conceptually it is that elevation is the distance. You can't type all that in a bloody 200 letters.
Yeah, that's the problem. Trying to have a technical conversation in any depth at all when you're just out there in the YouTube chat is virtually impossible.
Yeah, so but it is surprisingly large, isn't it? I remember about 2 years ago with George, actually, we were suddenly wondering if this was an issue for determining the hidden value of things. And of course, the difference between two ends over that sort of distance, it doesn't really matter. But it's quite large, isn't it? The bulge is more significant than you might think. The difference it has, and the reason I questioned you about the 100 meters or the 100, you put it as 100 feet, didn't you? Unfortunately,
yeah, it's a typo on the slide, is all.
Yeah, is that I thought it was less than that. That's why I was confused. I thought it was only a matter of a few meters over the distance. Oh no, this is 10 miles. Oh, of course, this is 20 miles, isn't
miles,
it?
Yeah,
of course,
miles.
yes, sorry,
yeah.
Of course, yes, so that would account for it. Yeah,
there are online calculators, and of course you can do it too if you've got the reference ellipsoid. You can figure it out yourself. But there are some handy online calculators as well that where you can go and stick your latitude in. And
that's right, and they also account for. Sorry, Karen.
And it will give you the radius at that latitude.
Yeah, I've seen them. Yeah, I just couldn't remember. I should have done that while I'd forgotten that it was so large. It just shocked me a little bit. But of course, it's 20 miles long, that bloody bridge, and so yes, the difference is, and it's also almost north-south, isn't it? So
yeah.
So it's exactly all the things to maximise the value. And I remember I was worrying about calculating drop values and other things and whether it was affected by that thing. But yes, 100 meters is a fair old distance due to the bulb. I think, it's obviously 16 miles over the whole from the North Pole to the difference between the North Pole and the equator is 16 miles radius. And actually, when you even if it was uniform, it's surprisingly big. How much it's got to change.
Right.
Yeah, it is.
Yeah, when I first did and I've got that graphic up on the screen right now. If you're watching my live
I am watching it. Yeah, I'm looking at it. Yep, looking at it.
Yeah, that. What was I about to say? It's quite a distance there from the left yellow dot to the right one is about 24 miles. And so 300 meters or 100 meters different, or 110 meters. Is not at all surprising. In fact, that's exactly what it should be. I think, in fact, when I put it in an online calculator, I came up with 109 point something. That's what the calculator said. So, close enough within reason.
Why did you draw the white lines in that diagram?
To indicate to them, and I really should have put a couple more dots in there. But really, all I'm showing is if you consider just those 3 points, you don't have a single horizontal. You've got two of them. And if we put 2 more points in midway between, scattered.
Sorry, you're saying the white lines are horozontals for something?
Yeah, that would be. You could consider that
horizontal, the midpoint between the blue, red, yellow dots.
Points of equal elevation. Okay, they're connecting 2 points of equal elevation. So that could be, it would be a horizontal that would be tangent to some elevation. Not either one of
At
those
the
elevations,
midpoint
but
between
at the midpoint.
as a midpoint between the two yellow dots. Yeah, I
Yeah.
think one thing, Blue, you should. I think you should annotate your diagrams a bit more because I couldn't quite understand what was going on there. I mean, I know it's a pain because I do it, and it takes me hours and hours and hours. And I've got all these diagrams I'm trying to do for this video and things, and it does take hours, I must admit, so I can understand why you.
Yeah.
But it was but yes, you then gave them. They then started talking about teepees and things. Whereas, of course, it's really the red line you're trying to show there. That's the line of the bridge, and you were just sort of cutting through from two sample points.
Now I've moved forward a little bit. Now there's the two zeniths, or the two radials, or the two perpendiculars.
So of course they started getting confused about where the horizontal was for the. I think they realised it was a horizontal. I mean, you haven't actually said it's a horizontal on there, but obviously it becomes one for the midpoint between the two, and you need to sort of draw in there the trouble is if you're doing the horizontal for any point. What you needed to do was to put a yellow blob where you've got that new white line, the vertical, and put it on the red line and say that this line is a horizontal for that point. Whereas, of course, what you've done there is you generate a horizontal underneath the ground, underneath the water almost.
Well, what you figure out after you do these things for a while is that once.
I mean, these people are stupid. I suppose the point I'm making out, Blue, these people are stupid. I mean, you're obviously, to me, obviously, it's obvious what you're doing, but to them, they're going to, they willfully try and misunderstand it, and they will do their best to misunderstand it, and you've just got to not let them do that by, putting in labeling things with horizontal.
Yeah. You got to cover every possible tiny nit shit little detail. Then you end up with a 2.5 hour video that nobody will watch. That's the problem.
Well, no. The diagrams you have to spend ages on. The video could be the same length, but the diagram could be sort of better annotated. But I mean, you're up to this, Blue. I mean, God, your little paper on Cavendish, Christ's sake, you were. Admittedly, that did take you 3 months or something. I don't know how long to take to write the paper, but but bloody hell, that's a fine piece of academic work, and just your previous history in that. I mean, scientific research, really. I mean, you're clearly capable of doing the rigor and things, but these people will misunderstand something if they can. I mean, they just didn't understand it. I mean, Blue and Bev and Essie really just couldn't understand what was going on at all. And they thought it was a teepee or something you were drawing. They didn't realise that because you didn't label the white lines as horizontals for anything in particular. So they thought that was, God knows what they thought. I mean, we're trying to work out one idiot. Go ahead.
I really like. Sorry.
No, y'all go ahead.
I really like GeoGebra for doing illustrations.
Yeah, it's good.
I'm not really good at math, but I can visualize stuff really well. And when I can visualize it in GeoGebra, and it gives me the math, which is really awesome.
Yeah, it's good. It's good. Yes, it's a lovely little program. It's very small, and you can load it in. It's and it does a lot of really useful things, like being able to determine the angles between things and stuff like that.
And, like angular resolution.
Yeah.
Like the sun to get to 1 degree above the horizon would have to be out 350,000 miles. And then from then, it's just an asymptote. Never gets
Blue, one thing. Sorry, Sean. Blue, when you said distance from the origin, did you deliberately avoid using the center of the Earth because that's not quite aligned with the center of the Earth?
Actually, it is. It is pretty well aligned with the center of the Earth.
I thought it was. Yeah, I just wondered why you hadn't said. It would have just been a bit easier if it said distance from the center of the Earth. That's all.
Well, yeah, and then you get all of the sticks and stones and slings and arrows thrown at you for using the term center of the Earth.
Yeah, but you're drawing a curved thing here.
This is literally distance from the origin of the ECEF coordinate system.
Right, that's true, I suppose. So what you're saying is you're just trying to use the coordinates. You're not trying to presume anything. You're saying this is the data, this is the origin of it, and there you go. So yeah, so okay, I can understand that actually. Yeah.
Right, yeah, that's my standard speech when it comes to that is the Earth is secondary. We're talking about the ECEF coordinate system, and regardless of whether there's an Earth there or not, that coordinate system is there. That exists, and its origin exists.
Yeah.
So you can take the Earth away completely, and all of these positions are still accurate.
Yeah. Yeah. No, I can understand that actually. Yeah, because you're just trying to go from empirically, here's the data I've got, and that's all I'm doing, and I'm not actually saying you're not superimposing an Earth on it, even though obviously no, it is the center of the Earth. But yes, I can see that actually. Yeah, yes, and yeah. So I couldn't explain to Bev. Well, obviously, as you're saying here, the elevation is defined. Is from the, as you said in one of your posts, it's from the equipotential surface, i.e., where the water level of the ocean is, defines zero elevation. But conceptually, that's why I tried to put in that little post. I think conceptually, of course, we think of, or perhaps an approximation or some concept, I'm not quite sure which, is obviously from the distance from the centre, but because of this silly bulge, the actual distance from the centre of the Earth for the same elevation is greater at the equator than it is at the North Pole, and you're demonstrating this, and that's hence your difference in the distance. Even though, of course, the two ends of the bridge are at the same elevate. The causeway at the north end and south end, I presume, are the same distance above the water, so therefore have the same elevation, but they're slightly different from the centre of the Earth because of this bulge.
That's
well,
correct.
100 meters actually. Yes, 100 meters. I suppose it's a bit more than this. Yeah, it's not intuitive. You think I do keep on being caught out about that. You think, oh, this is little bulge business, but you know, this is why they had to go to great lengths to measure it in the 18th century, that expedition that Larry and I keep on talking about in the 18th century, where they determined whether Newton was correct and the Earth would have a bulge and all that. But you know, there's a real 100 meters over 20 miles. That's a big chunk of difference. So yeah, I do keep on forgetting just how chunky it is, that difference.
Yeah, I'll be right back. Hang on, you guys talk amongst yourselves. I'll be back in a second.
Rumpus.
Hello, Alan.
I can tell you that at my latitude of 52.71 degrees north, the local radius is 6464642 meters, as against the average of 6371009.
What's the difference? I couldn't remember exactly what you said there. What's the difference?
Sorry, it's
how many meters?
Here, it's actually smaller. It's actually smaller than the mean.
Right.
Because here it's 6'3", 6'4", 6'4",
Ah, right, 6'3", 6'4", right, okay.
63, 64, 64, 2 meters, and the mean
is of 8 kilometers. Then. That's a difference of 8 kilometers from the mean.
Yeah, about that. No, 6.
Sorry, 6. Sorry, 6. You're right. Sorry, 6.
6 and a bit.
Yeah, 6 and a bit. Sorry, 6.
Yeah, 6 and a bit. Because it's 6371009. So 6371 kilometers and 6364.6.
Yeah, it's a fair old chunk, isn't it? And of course, as you say, we're quite close to where you'd expect the mean to be, really, because we're sort of not quite 45 degrees. You could argue sort of halfway between the equator and the North Pole, and here at 54, and it's so you'd think it'd get quite close to the mean, but no, it's even 6 kilometers out. It's a chunk, isn't it?
Oh, yeah.
I think because you have to remember that most of it is going to be quite close to the equator.
Yeah, indeed.
No,
it's not going to be linear.
I agree with that now. There's not a big whopping bump in the center of the Earth, Alan. It's a pretty steady transition from north to south.
Is it? Well, I suppose it's going to be proportional to centrifugal force, which is, I suppose it would be radius. Right, it's going to be turned on the radius, isn't it? Which I suppose is linear. Yeah, you're actually right. Yeah, it's a linear change, isn't it?
Well, if you just run through the math, you figure the distance from the North Pole to the equator is about 6,250 miles, roughly.
Yeah.
And if you assume that bulge is 16 miles at the equator, the radius is 16 miles greater at the equator.
Oh, well, surely it's going to be a side, isn't it going to be a? Sorry, I think I might take that back actually, because surely it's going to be the centrifugal force or the bulge is going to be dependent on the radius, but the radius is a function of the cos of the latitude, so it's not going to be linear, surely.
No, it won't be. No, I agree. It won't be linear, but it's not all piled up right at the equator.
Oh yeah.
That's my point.
I wasn't trying to imply that it was all piled up at the equator, just that it would be.
Yeah,
Yeah.
I think we know what you meant.
What-
And I knew what you meant anyway. Yeah.
Yeah, it wouldn't be. It wouldn't be. Yeah, it wouldn't be completely even from the
It wouldn't be
equator
linear, basically. Yes, it wouldn't be linear. Yes,
to the North
it's
Pole.
not linear. Yeah. So yeah.
Well,
yeah,
if you
so
figure the change is linear, you can do the numbers yourself. You'll come up with 324 feet over 24 miles.
Right.
Okay. I mean, yeah, all I was basing it off was having got my local radius from one of those sites on the interwebs that will give it to you based on your latitude that you mentioned earlier, Blue.
Yeah.
Yeah.
Which one it was now I can't remember because I grabbed that information and put it into a spreadsheet more than several years ago.
Yeah, it's just surprising how chunky that is. I mean, like you sort of dismiss it as a sort of intuitive thing, and of course, the Earth I think is more spherical than a billiard. I mean, the difference. I think in comparison to billiard ball, I think it might be a myth actually. That's or was that Everest? No, I might be getting myself. Of course, Everest is how tall is Everest in miles? That's about 4 or something, isn't it?
That's
yeah, so it's about a
5
quarter.
miles.
So Everest is so it's about a
little over 5.
quarter. Yeah, so it's about a quarter, or somewhere between a third and a quarter of the difference between the North Pole and because it's 16 miles difference between the radius at the North Pole and the equator. Everest is 4 or 5, so it's about a third. Okay, it's perhaps near a third so Everest is a third of the difference between that exists between the two radii.
Oh yeah.
Yeah, so it's not something you can ignore. Yeah, I keep, as I said, with George and I were discussing it 2 years ago about the difference it would make to possible calculations of the hidden amount you see when you're looking over the horizon, that something's hidden by the horizon, and we decided in the end the difference relatively wasn't important.
No, I don't think there's enough that over the distances that we normally talk about.
Yeah.
That you're ever really going to be able to tell it.
Yeah.
Hey, good morning, guys. Good morning.
Hi, hello, Wally.
I see we're all having a lot of fun at Bev's expense, which is as it should be.
Yeah, absolutely. Yeah.
Oh, clearly.
Yeah.
Yeah, no, he was well broken by the fact that you had put the little apostrophe mark at the end there. I'm saying no, it's actually meters. If you go and actually just Google what the Earth's radius is, it's got all the same numbers at the front. So I'm pretty sure it's meters. He's no, I think it must be feet. Poor guy.
Yeah, he can't do numbers, can he? Anything with a number in it. That's it. That's why he likes Euclid, because there are no numbers involved. And of course, no one uses Euclid for anything useful at all. You use bloody analytical geometry, which you can get numbers out.
Yeah,
but of course, he's allergic to numbers.
I tell you what, a fun thing to do with them is to say that Euclid's great. It's a really good for a 101 first day course on what to do. After that, we all go with some more harder stuff. And, did they rip into me for that?
That's a good one. That's exactly right, Wally. Because I've always. This is why we don't do anything with it. We don't mess around with it. It's a historical thing. It's not useful to anybody. You've got to go and really use equations and things. You don't use any Euclid crap.
It's a picture. It's like a picture of grandma. It's really nice to have, but it really doesn't help you with anything.
Absolutely, yeah, exactly right. Yeah, and because he hates numbers, he can't do numbers. I mean, he doesn't even know what a radian was. In fact, yeah, that's right. I think Blue discussed before. He didn't know what a radian was. I've never seen him do a calculation ever. And so, of course, he's allergic to numbers, and therefore that's why he loves Euclid. He can just do this sort of stuff that we would dismiss, as you say, on a first course. It's interesting philosophically, and obviously this idea of a non-Euclidean space is a conceptual thing, and that's something that's worth getting to grips with. But there's nothing in Euclid you would actually use in a piece of software, or you would.
Yeah, well, it's a wonder he doesn't know what radian is, because one of his little flunky minions, that J-Ro, I think he can only ever do anything in radians. He can't do anything else but convert it to radians. That's all he seems to do.
Really? J-Ro,
J-Ro,
yeah.
J-Ro, he just loves radians. Always radian this, radian that, radian.
Well, he's the guy that claims, he's the guy that has tried to claim that he's an aeronautical engineer.
That's what he says he is.
Yeah,
yes.
Yeah, he said that, and I asked him to give me the lift equation, and he couldn't do it.
Yeah. Oh, look,
Really?
one.
Or is he just someone who changes the tires on airplanes or something?
That's
look,
what
I
I
don't
don't know.
know.
I don't know. He might be an A&P or something like that, aircraft or a airframe and power plant mechanic or something such. But
I'll tell you a funny story. A couple of months ago, I had Wolfie and I were playing with each other's telescopes, and I didn't mean that to sound quite like that, but he was on my computer, and I said, "Look, just jump on the Chrome there. I've got the Discord is open, right, pointing at Bev's group. And have a go at them while I go and off and do a few things." So then Wolfie was Wally for a few hours, and he had J-Ro all over the place, and eventually got down to the fact that J-Ro couldn't tell him anymore because it's all military secrets. So he had to fall back to the military secrets. I can't say anything.
yeah, I can't talk about that.
You know, with the right accent, sanitation and aviation can sound a lot alike.
Yes, that's true. That's true. I push the broom under planes. I'm around planes. It's a bit like the old Seinfeld skit where men like to be where work is being done. We don't like to actually be doing the work. We want to be near where the work is being done.
Yeah.
Yeah.
I think. Yeah, I mean, if he doesn't know the lift equation, I mean, he can't even. Yeah, I mean, he must be doing something to either cleaning airplanes or just changing the tires or painting them or fueling them up or something.
Yeah, I mean,
That's it.
I'm not. All I do is fly airplanes, and I know what the lift equation is.
Yeah, quite. Yeah, I mean, right. Okay, so yes, I mean,
I used to get baby food. I used to get baby food in a little spoon and do whang to my kids. Does that count?
Yeah.
Well, yeah, apparently, yeah, I think they probably do. Yeah. Yeah, I mean, he doesn't know what radian. Anyway, Bev doesn't know what a radian was. I think it was about 6 months ago, and I think Blue spotted this as well when he said radians. You needed to know the distance or something along two lines to know what the radians were between separation between two lines, and so he doesn't even know what a radian is. And perhaps he does now. I don't know. But
yeah, I thought this little diagram I had on the screen would be near and dear to Bev's heart. I mean, there are Euclidean proofs of this shit. Okay. You can find these in some of his postulates.
It's got it's not an equation in it though, Blue. It's got pluses and equals and things in it.
When Bev got to the diverging zenith part of it, he quickly went to the wrong side of the diagram. He quickly went to the side where the zeniths are going to converge and make a triangle. Because, I don't know, as far as Bev's concerned, if you can't make a triangle out of it, it doesn't exist.
Yeah.
Well, Euclid also stated that the surface of a sphere is two dimensions, that which has width and depth.
Yeah, somebody was asking that out in the chat a minute ago.
Yeah, Blue, I haven't seen that video, and I was so busy fighting with them in the chat, I didn't follow exactly what you were doing. But I did get the impression that I think they genuinely, as well as not wishing to understand what you did, they genuinely didn't understand what you were saying. All of them were sort of asking one another and coming up with some strange ideas. So I'll have to have a look. Damn it! I wish I'd seen your video before I chatted to them. They're just bloody stupid people, really. Oh God.
Well, the concept is devilishly simple. I mean, can you measure?
Yeah.
Can you or can you not measure zenith angles and their divergence or determine whether they're parallel or not? And yeah, you can. If they're diverging, the sum of the angles has to be greater than 180 degrees. That's the end of that. And all you got to do to measure it is this. Nothing more than that. Take two theodolites and put them at two different, substantially different distances, places where the distance between them is relatively big. 10 miles or so is good. And point the damn things at each other and measure the angles.
Bev hates that, doesn't he?
That's
He
all you
absolutely
gotta do.
detests pointing two theodolites pointing at one another. And I'm not sure whether I'm trying to work out whether he's allergic to that because he realizes that exposes his fallacies, or whether he's got this aversion to it because somehow he's never done. I mean, he's still going on about this Blackpool thing as though his motive for taking that image is more important than the information in the image. So, if you had a murder going on in that image, he would still be saying, "Oh, don't look at the murder that's going on in there. I want you to be looking at me."
Right.
No, we're interested in the information in the image. We don't care what your motive for doing that, taking that stupid image. We're analysing the image and then telling you what's important in it. We don't care what you think's important. We're telling you what is important in it. Stupid bastard. I mean, honestly. But yes, and so yeah, I mean, so yeah, he hates these theodolites looking at one another, and I'm still not sure whether that's because he just doesn't like the idea, or he sort of suspects it is exposing his stupidity. Because I think it might be a bit of both, actually, because he really hates doing it when it's such an obvious thing to do. It exposes the, as you say, it's a really good way of showing that the verticals are diverging. It's a really good way of showing that the Earth is curving. So I can understand why you're keen on it. Indeed, I use that as an example in one of my things for the curvature of the Earth, and as a good example because it's something you can see readily if you've got two theodolites.
Yeah. You can, well, I mean, there's no reason why you can't do it with one theodolite if you really wanted to, but it's better to do them simultaneously because then both are looking through the same atmosphere.
Yeah, but you need obviously, if you do move one theodolite, you obviously need to sort of put something in its place so you can sight it with a theodolite.
You got to be able to see the location where you were set up. Yeah, no doubt about it.
Yeah, and the height as well. Yes, you need something at the right height.
That graphic on the screen is what Bev hates. The fact that it absolutely every time that's done at any sort of reasonable distance, you're going to get an angle that exceeds 180 degrees every time.
Yeah. The trouble is, of course, that diagram to him means you're dealing with a flat Earth in effect, because he doesn't understand that the base of that diagram might be horizontal on screen, but it's representing an arc. And of course, he refuses. I don't think he's actually understood that's what it is. And this is why I say to him, if he thinks that a test of a flat earther is whether or not they think the elevation is a series of points at the same elevation form a straight line, he says, well, look, it does in the elevation diagram. And of course, it's because he doesn't realise that base there represents an arc. So that's another sort of level of.
But it's a diagram to show you elevations above.
Because the point is, the reason you do it that way, of course, is that you want to be able to compare things at different elevation. If it was curved and demonstrating the curve of the Earth, then you couldn't just draw a line of a grid like you've got there. That could then be curved. Yeah. But it's much easier to say, oh, look, from this diagram, you can see, say, along there, you've got 6 points something along to the right. You can see there's a couple of bumps there, and you can say, oh, look, that's higher than the bumps over on the left-hand side. But you couldn't do that by just using a simple horizontal line. So obviously, all elevation profiles are presented like this, where the base is a curve, but we put it in this manner so that you can easily see the horizontal differences in vertical elevation.
That's part of it. But there's actually just a practical reason for doing this way.
I appreciate you were saying you were saying the drawing the draftsman, but surely it is just more useful, is it not, to have it in this form?
It's perfectly even if useful the way it is. We know that the verticals really aren't. They're all leaning away from each other. If you did it in reality, you'd make that center vertical, and all the rest of them would get progressively lean further and further out. But that's over 10 miles, and you're only talking about 4 arc minutes. If I drew that to scale on this drawing, those red lines would still look just like they do. You would not see it. If you drew Earth curve in here over 10 miles, over that distance, that even though you draw it as an arc, it will still look just like a straight line. You won't be able to tell it.
It's only half a degree. Yes, was it 40 miles? So it'd only be half a degree or something, or 2/3 of a degree between.
1/7 of a degree, basically.
Well, it's 60. So how many?
20 miles per degree.
24 miles. Sorry, yes, it's 20. Sorry, it's 11 miles. Sorry, it's 11 miles you've got there. Yeah, right. Okay. So it's 1/6. Okay, yeah. Sorry, for some reason I thought we were looking at the. I was in Lake Pontchartrain mode. Yeah, right. That's just an 11-mile one, right?
That's exactly what I was going to say.
Right. Sorry, Sean. Sorry, Sean, for cutting you off.
It shows flat, but it basically looks flat at that, at that range.
Yeah, I mean, the Earth is very flat. I mean, for Christ's sake, there's a difference of 1 degree over 69 miles. You just can't see this. I don't know, if you're doing something surveying and you're setting out something as a plane of survey to your building, and even over 100 meters, it's only 1 bloody millimeter. So all these plane surveys, they never ever have to worry about the damn thing. It's just so tiny. The Earth is a very big thing. It's
Yeah, but-
very
Yes, it is.
flat.
But Snellius, Willebrand Snellius, the Snell's Law guy, was also a surveyor, and he surveyed a bunch of churches in Holland and in like 16 something, and proved that the Earth was curved within, I think, 3% of the accepted value.
Right. Yeah, that's right, because he was around. Yeah, right. He was around the 17th century, in the 1600s. Yeah.
He did it with
Right,
a
look at that.
big ass quadrant too.
Right. Yeah, I mean, so, I mean, and then I had a question from Mobius or something, or what, I think it was Mobius, asking how, or someone was asking, was it asking, one of the two, asking me how do plane surveyors, that's right, that he's asking how do you know when you see a difference in elevate in the crosshairs of your theodolite or auto level, and you see a change in what appears to be elevation, how could you distinguish that between Earth curve and an elevation change? And I simply said, well, if you use backsights and foresights, you can eliminate the Earth curvature, and that apparently was a shock to him. He didn't think, I was making something up. Yes, so which is something I was only really learned about a year and a half ago, was that I couldn't understand before then why all this backsight and foresight business, but the fact that it eliminates the curvature of the Earth and refraction as well is just such a marvelous thing that even if you were dealing over distances that were going to be affected by, you were interested in a millimeter or something, you can even eliminate that by just doing backsights and foresight business, which is what most surveyors do when they're doing stuff.
Yeah, you wipe out collimation error, you wipe out curvature, and you wipe out refraction all in one step.
Yeah, it's amazing.
Nothing matters because whatever refraction and curvature and collimation problem you've got at the foresight is exactly the same as what you got at the backside.
And Bev doesn't know anything about this, does he? I mean, Bev, he claims to have a certificate. I mean, he does have some sort of certificate. By the way, for people, it's a GCSE, which is in this country is a certificate that is an exam you take when you're 16. So I think he took it when he was 21 or something. And I mean, he's never read. He doesn't seem to have ever read a surveying book. I mean, if he had, I mean, I don't understand these people like Mobius and others who go on about this stuff. I mean, they only need to look at Rakia, for Christ's sake, who does this as for a living. He actually does, unlike Bev, he actually does it for a living. He hasn't got any surveying books. He did say he'd read a chapter, and he did say that the chapters he'd read on the subject did agree with what I was saying, but he somehow, I haven't quite worked this out. He seems to have read some chapters, though he hasn't got any books, or he claims he has, but he hasn't read them or something, or he denies them. But it doesn't affect his work. So although he is aware that surveying books have what they say,
he's pouring concrete for sidewalks and foundations. Like you say, you can pretty much ignore the curve of the Earth for pouring a sidewalk.
Yeah.
Well, I've been asking him time and time again to tell me the name of the book that he used, if he can remember.
Yes.
Tell me what book was used in that course he took.
Yes, because I asked him. He said that initially when I was having a shouting match with him, he initially said that I was wrong, and the book. I said all surveying books, I said, will detail the curvature of the Earth and how you take it into account. And he said, "What, all of them?" And I said yes, and then he said, "Oh, not mine." And I said, "Okay, you tell me what your book is, and I will go and download the book, and I will then tell you the page which it shows it." And then at that point, he then said, "Oh, well, I don't know exactly the name of the book, etc., etc., etc." So
it's like celestial navigation books. Page 1, they talk about the globe.
Yeah.
Page 1.
Oh, you got a note in the chat there, Rumpus, from Mr. Malort.
Oh, am I annoying someone?
Yeah, he says, Cheers, tell Rumpus to stuff it. Laugh out loud.
Is that telling me to shut up?
Where are we posting?
No, he's just messing with you.
Where are we posting?
Okay. Thank you, Blue Marble Observer.
Blue, where are we posting?
Marlow.
Which room?
Marlot.
Blue, where's the chat? I'm sorry.
It's on YouTube.
Which one are we posting in?
YouTube chat.
I'm not watching on Discord.
Someone I thought was hassling me, but they're not. Apparently, or something. Okay. So yes, I actually pinned him down, and he was on the verge of telling me, and he did say he had a couple of books actually, but he wouldn't tell me what they were because I was then going to go away and download the Little Devils and then point to me the exact page in which it shows. Because obviously not every page. I mean, you say page 1, paid NASA, but it's not on every page that they go into this. But I was going to download the book, find the page with the curvature, and show that level was not horizontal, because there's always a diagram in there somewhere with the level curving and then comparing it to horizontal. And I was going to do it, but he claimed, he then said joke. I mean, he said it was a joke. I think he was in the bath and therefore he couldn't go up and get the book. So I mean, these people, and he claimed, they claim to be.
Well,
it's got to be dishonest, hasn't it? Really.
Bev tried to claim that reverse or reciprocal zenith angles are not a common surveying practice. Really?
Huh.
Well, here's a 1978 NOAA publication where they did 7 sets of them. And guess what? Hold on a second. Ah, damn it.
Well, let's go. Did you hear
That
him,
would
Bev?
make a perfect politician, wouldn't he?
Yeah.
Bev, did you hear Bev say he didn't think you'd ever done a 2-peg test? As though, I don't think he knows what a 2-peg test is. Which, I mean, hopefully, I presume you'd agree with me, Blue. It is a way of testing the collimation on your auto level or whatever.
Yeah.
But he seems to think it's some measuring thing. It's something like differential leveling or something, or some part of that. I think he's getting mixed up with.
I've heard him say that the very first thing you have to do, the very first thing every surveyor does when they get their equipment out, is do a 2-peg test. I've heard him say that.
Yes.
Now I got to tell you, I've been around. I don't know how many surveyors in my life, lots of them. Not once have I ever seen a surveyor do a 2-peg test ever, for any reason.
Yeah, I mean, it's something you do it perhaps everyone. I mean, if you're bashing the thing around, you might do it, I suppose, and just to check it. But I don't think he realised it's a calibration test.
That's all it is.
But I think he thinks it's some sort of because he said, I don't know if you caught it in the at one point. He said, that bloody blue or something to the words to that effect. I bet he hasn't even he doesn't know anything about surveying. I don't think he's ever done a 2-peg test. As though what?
I'll bet
I've done a 2-peg. I mean, I've done it. I mean, I've done a 2-peg test. I've calibrated the auto level I've got when I was doing it for Rect, and to check it was accurate enough, and it was. But I don't think he knows. Though he's talked about it repeatedly, and he doesn't. And he was accusing you of not having done it, therefore you're not qualified. But I don't think he even knows what it is. Well, he doesn't know what anything is, does he? I suppose perhaps I'm giving him too high hurdle. He doesn't know anything, does he? He doesn't know how to do maths. He doesn't know about geometry. He doesn't know about Euclid. He doesn't understand what surfaces are. He doesn't know anything about surveying. He's a moron. Why am I expecting him to know more? That's. Oh.
Well, I have in fact done 2-peg tests. I have in fact used theodolite before. I've used dumpy levels. I don't know if I'd love to see Bev's one of those old dumpies that had the 4 adjusting screws. I'd love to see Bev try to level one of those. That would be hilarious.
This data you've got here, Blues, is this something? I haven't watched your video. I meant to. I say it's on my to-do list. Is this your data or is this someone else's?
No, this is NOAA data from 1977, 78.
Ah, right. Okay, from the thing you just mentioned. What is this plumb line tilt? Because that's a rather worrying term. I must admit, I didn't like the look of that term. What does that mean?
Well, that's a surveying term.
Is it? Oh, okay. I didn't know that one.
Yeah, I think that's the way it was published in the paper from NOAA. I got the slide I got it from Jesse, I think, or maybe Larry. I don't know which one of the two.
So what does plumb line tilt mean?
It means the excess in over 180 degrees, the excess in the zeniths, the summation of the zenith angles.
All right, that's a rather odd term to use for the sun being. To call it plumb line tilt.
Well,
I suppose it's
gives you the sum,
like,
okay?
Right. I mean, surely is it just
sum of zenith angles, 180 degrees, 15 minutes, 53 seconds. That means the plumb lines are tilted apart
to one another,
inclined
right?
From one another by 15 minutes, 53 seconds.
It's just the excess over 180 degrees.
Yeah, that's all.
Yeah, right. Okay, it's a very odd way of putting it. Yes. I mean, I would just say it's a separation between the verticals or the zeniths, rather than to say calling that, because both the plumb lines are obviously not tilted themselves, but they have a divergence, an angular separation of that value is what that's saying, right? Okay, so that's the angular separation between the two plumb lines. Okay.
Well, again, we can split hairs over the words, but we know what it means. It's obvious. It's right there on the screen.
I assumed that's what it was, but
Yeah.
yes, I just thought it was a rather peculiar way of describing
You
it.
can see it right there. Because a stop was 180 degrees, 15 minutes, 53 seconds. That'd be good enough.
Yeah.
I
So
don't
it's just
have
the
any
1 minus
problem
180.
subtracting 180 from all those numbers. That's easy.
Yeah, so as I say, I hadn't seen the video, so I just saw it briefly in Bev's and wondered, well, that's a rather odd way of describing it. Right.
How much does a theodolite cost? If I wanted to go out and buy one of theodolites are us.
eBay ones, second-hand ones aren't too bad. I mean,
You can find second-hand ones for, I don't know, $300-400 probably.
Just wondering.
As much as that.
What you want is a total station.
George was going to give me one of his bloody total stations when he came over. Or give it to me at a very cheap price. Was he one of his electronic ones? That was.
Is that the one to talk to the satellites?
They can. The total stations will actually measure distance to your to a reflector and all. You don't have to pull a hip chain to whatever distant rodman you have. You can actually measure to the prism.
Yeah, so it can actually tell you what the elevation is of something in the distance. So if you're pointing at, say, a tree or something, a bit of a tree or building, and you point to a particular bit of the building, it can say, and it will account for the Earth curvature because it knows what the distance is, and then tell you exactly what the height of that thing is, which is quite something. That's why they're useful. So the little EDMA laser thing in them. And the thing is, of course, the catch on these things is when the McToon nearly he didn't get caught out, but someone tried to catch him on this. I can't remember who was debating a week or so ago. Someone was saying, oh, look, these bloody theodolites, they've only got a range of 1.6 kilometers. And of course, as per usual, whenever you hear that, it's always the range of the EDM part, the distancing thing, and the angles, of course. And this is something that Bev doesn't understand, the idea that you can't measure there's no limit to the... Well, you could use a theodolite to measure the difference between two stars, if you could see the damn things. So there's no limit on doing angular measurement, but the EDM obviously is limited by how far the laser can determine distance. So that's where, if you ever hear a limit about theodolites, it's the bloody EDM laser distancing part of it, not the angle measuring bit.
And that actually can be changed by the type of prism. You could have a multi-prism set up to where you could actually extend your range quite a bit by having a 4-prism setup.
Right.
But they usually do the distances at 1.5 kilometers, and the accuracies on these things can be 1.5 millimeters at 1.5 kilometers.
Jesus.
So they're extremely accurate. There's no way you're going to pull a tape measure and get that kind of accuracy.
In distance measure. But tape, you need a real physical measurement. You can't measure with light. You actually need like a world-sized tape measure to go all the way around the Earth in order to prove anything.
Yeah, well, I had a discussion with a guy about that. It ended up devolving into he, for some reason, thought that the plumb bob was used to level the theodolite, and that turned into a 2-week conversation about what a plumb bob was used for with a theodolite. And I told him, I said, most of the time the plumb bob's not even used. In fact, it's almost never used. They use the optical plummet on the tribrac.
Yeah,
sure.
And that is not necessary.
Well, in the old days, they had to put the plumb bob over the mark, right?
Yeah, well, that's one way of doing it. You can still do that. You can still hang a plumb bob under there and
you hang a plumb bob
over your benchmark. But then
over the benchmark.
The reason that big mount is so sloppy, if you've ever messed with one of these things, when you unscrew the nut gizmo that holds it onto the plate, you can move that damn thing a good inch any direction. And the reason for that is so that you can look through the optics and center it exactly on your benchmark.
It's been a long time since I looked through a surveying scope.
Yeah, they're great fun. I must admit.
That part
not
is
really my
actually
argument.
just a 90-degree angle that measures down, that actually looks down at the ground, and that's usually not even part of the theodolite itself. That's part of a separate base called a tribrac.
Yeah.
And that's what actually the leveling is done, is in the tribrac, and that's where you align everything, is in the tribrac. And then there's a cam lock that actually locks the theodolite to the tribrac.
Like I said, whenever they talk about this, I shut up and they ask me questions. It's like, no, this is not my topic. And go talk to someone who knows.
I mean, pay NASA. I mean, here I managed to get a decent auto level for about £25, so about what, $30 odd dollars, and I managed to get a decent decent tripod for another 20 odd pounds. So for about $50-$60, you can have an awful lot of fun with them. You could have, if you feel like fancying, you can have a lot of fun for $50 basically, if you go on eBay, and it's worth playing with.
So is that cheap? I thought it'd be more than that for a.
For an auto, this is an auto level, not theodolite.
Oh, okay.
But you can have lots of fun.
No, you can buy auto levels. You can buy auto levels at Harbor Freight.
That are free, did you say?
Harbor Freight is the name of the place. Cheap tools.
Right. Yeah. And of course, the other thing is that Bev, and that just to demonstrate just what an idiot this guy is, he didn't know that theodolites can show you the horizontal, and he wanted to have this debate with, was it George, a year ago, longer than that. George was having to explain to him how a theodolite can show you horizontal, and he just didn't believe it, and he didn't understand that the compensator mechanism to show you what horizontal exists inside a theodolite just as much as it does as inside an auto level. So you have it has effectively a plumb bob inside it to give you horizontal. Obviously, electronic ones.
Yeah, the modern ones do.
Yeah. So I mean,
Any theodolite manufactured probably in the last 30 years has got a compensator in it.
Yeah, and he just didn't accept this. He's only ever used an auto level, so that's all he ever thinks about. He doesn't understand. He's never used a theodolite. It's obvious to me, and therefore he doesn't.
You still
know
determine vertical first. Is horizontal still determined from vertical?
Yeah,
absolutely.
Okay. That's what I. Yeah, I guess these guys are always going. You establish the horizontal and then the vertical from the horizontal. And going like,
that's
no,
right.
that's
they
backwards.
get it around the wrong way. Stupid bastards.
No, it's the vertical you establish.
Right. Because the verticals are not, and that's the problem. The verticals are not parallel.
Yeah.
And the horizontals aren't parallel.
That
So
means
of course, people like
exactly.
Oh no, I had at one point Blue is going on about this idea that you say, oh, those three conclusions at the end. Oh Jesus, and he thought those were novel. I mean, Jesus Christ, how many times have people told him those three conclusions? I think the guy's got some mental problem. He just doesn't remember, or pretends not to remember, or something, what he's been told about 300 or 400 times. It's just ridiculous.
Yeah.
And what was the other point I was going to think? I was going to go to the point I've forgotten now.
It's just interesting it's just interesting that they seem to think that the engineers that design the equipment don't know what they're doing.
Hey, Terry.
You know.
Sorry, I was buttoning. All this talk about what you're saying, it sounds like you're implying that level isn't horizontal.
Could be.
Hello, Terry.
Morning. What are you doing up?
Yes. It's only 1:45.
Yes. Yeah, Terry, it's not too late here. We're not in Oz, you know.
Yeah, it's only morning here. I don't know how you work that out on a flat earth.
Yeah, good question. Yes, quite. Yeah, so I was just shocked that when Bev didn't know that a theodolite. Again, he's like a typical flat earther. If it hasn't happened to them personally, or underneath, or in their bedroom, they don't believe it exists. So he has no idea how a theodolite works. He doesn't even understand angular separation. I don't think he doesn't believe you can measure angular sizes, because he never used a theodolite. And of course, he doesn't even understand basic trigonometry. He once, when I asked him about a year or so ago, more than that, about how to work out the angle between two lines, and he said you can't do that with trigonometry if you know the distances. He basically didn't know about arc inverse trigonometric functions, basically. But that's because he doesn't do any maths. And of course, trigonometry is not part of Euclid. Of course, there is no trigonometry in Euclid. The closest it gets to maths is Pythagoras.
Yeah, I've had several say that you can't tell how far an object is away just by getting its angular size and knowing its actual size. And I was like, I know a lot of people that use the reticles on their rifle scopes to determine the distance to objects. Seems to work pretty well.
Yeah, I mean the measuring rod thing is a classic one, isn't it? The measuring rod you go out with, you can, if you actually know what the size of it is, if you providing it goes between the two of the graticules in your auto level, you can then work out the distance that thing is away.
Yeah, the stadia is a sniper's best friend.
Yeah, the stadia. Yeah.
And is Bev actually wearing a Elmer Fudd hat?
Oh, the other major thing is he didn't understand. I don't know whether he does now. That the stadia marks are defined as being what's it? Is it 10 or 20 milliradians apart? Is it each one is 10 and makes it 20? I think, isn't it in total? And he didn't understand that it's an angular separation. The two stadia marks are defined as being an angular separation. He just thinks it all revolves around his measuring stick. As you know, he doesn't think an auto level works unless you've got a measuring stick in the picture. Suddenly, if you remove the measuring stick, it all stops working. You can't do anything with it.
And you can use lots of different measuring sticks, like a radio tower with a red and white pattern that are 50-foot patterns. Yeah, you can. That's a measuring stick. Look at that.
Yeah, absolutely. Or Blackpool Tower, as Blue has done here. He worked out the distance to.
We know Bev is just grasping at straws. I mean, the stadias are a ratio of 1 to 100, right?
Yep.
1 to 100. If you're dealing with a ratio like that, yeah, you're talking radians.
But he doesn't know why that is. He just knows that the ratio is 1 to 100. So he knows that.
Well, he's got a survey certificate, right?
Yeah, but from who? Yes, but it's for 16-year-olds. But he does not understand the stadia marks. The reason that it's 100 to 1 is because of the angular separation of the stadia marks. He doesn't understand that's where the multiplication comes from, the milliradians. He doesn't know they're separated.
Other instruments, you don't just have 2 stadia marks, you got a whole bunch of them. Just like you see in a rifle scope when you try to estimate how far away the buck is.
Yep. But he doesn't know, he doesn't understand. He only understands from practical uses. He's used a measuring stick. He knows he can multiply the number he sees in the...
yeah, if you can read the distance on the measuring stick, sure. The distance between the stadia marks on the measuring stick.
Yeah, of course, it didn't occur to him that if he reads between the stadia marks 1.45, that's 145 feet. He doesn't even know how that happened. He had to go 1.45, enter 100 times equals, right? He's like, he couldn't do that in his head.
Yeah.
When you said through a rifle scope, you did say buck, didn't you?
Yeah.
Yeah.
Yeah, I was just clarifying, sorry.
How you doing, Terry?
Good, mate. You're running late or I'm late. Has Rumpus been keeping the show alive the whole time?
I'm over talking everybody. Yeah.
Hey, Rumpus, have you given your Yelp review on the latest zenith angle video?
I haven't watched. You're talking about Blue's recent video.
Yeah.
Yeah. No. Unfortunately, I've been. It's on my must-watch list, but I haven't given it a thumbs up yet, but I will do, of course.
Oh, you can't be here without having seen it. I'm sorry.
Yeah, go do it. Go on, go.
Okay, I'll give it 2 thumbs up when I'm going to. Yes, I've been bad. Okay, I admit it. I've been bad. It was on my. I got distracted.
What surprised me in the comments, I have yet to see the words perspective or angular size asserted.
That is a little surprising, as fond as they are of talking about refraction and angular size and stuff.
No Riley criterion, no angular size, no perspective. They got some other wacky shit in there, but some of the most non sequiturs.
Yeah.
How would you have the Riley criteria over 10 miles?
Do we think that Bev could work out knows the formula for working out the angular size of something? I don't think he does.
I don't think so.
I think we're getting to him with that Father Ted clip.
Oh, Wait a minute. Angular size? Yeah, that's called stadia hairs. It's the same, man.
Yeah, I know, but I don't think if I told him the distance to an object and the height it was, I don't think he could work out what the angular size of that object would be.
No, I don't think
Of course not. Of course not. Just like a dip angle can only come from tables. No, you can calculate it. No,
I
it can
didn't
only
know
come
what
from
dip angle
tables.
was. Oh, Jesus, he didn't know what dip angle was. Brenda was
Yeah.
speaking to him about a week ago, and he didn't know what dip angle was. Oh,
Right,
God.
because they are sextant aficionados. It only works on flat Earth, and they know
And he
everything
also-
about it. And that
And he
dip
also
angle.
didn't. And he also didn't know why we think on a flat Earth the horizon should rise to eye level. He doesn't realise that that is a fundamental property of having a near infinite plane, that the damn horizon would rise to your eye level until
And
you
the
get
one-
Cut off the bottom of the building.
And the ones that do understand dip angle, they think that you have to put your the point of your eye line down to the water.
Yeah.
I've been trying to hammer them down on why there's a horizon altogether, and why we see further when we elevate our viewing. They still can't get.
Yeah.
They dance
Well,
around that and they obfuscate
sharp-
and they keep changing.
Yeah, when
Keep
they
changing
say, when they say, "Oh, we see too far for the curve," I go, "No, we don't see nearly far enough to flat."
Yeah, on a
There's-
flat Earth, yeah, we should see further.
Well, there should be a horizon. I can understand them saying there should be a horizon on the flat Earth, but the problem is there shouldn't be a sharp horizon on the flat Earth.
No,
It should be like
no.
some fuzzy thing that fades
Yeah.
out.
the
My new
blending.
question
It'll be a
is-
blending.
If the sun just goes too far away for us not to be able to see its light, or its light doesn't get to us, why at sunset when the sun is too far away to see, is it illuminating clouds that are straight above me or behind me?
Yeah, I've got a photo of that I took.
Don't ask questions like that. Come on.
Yeah. That's
Hey,
you're
the
getting
more
too technical
classic
now,
ones are
Sean.
Clouds, but it can't get to me.
The
You
more
get too
classic ones-
technical. You
the
get
more
too
classic ones
technical.
was-
Sorry, Sean.
Yeah, the more classic one is when the sun is just dipping below the horizon, is like cut in half, and that's like 2 minutes before sunset. It's not shrinking to a point, but they say trust your senses. Well, according to them, it's still 3,000 miles high and heading off to the right.
Hey, Blue, Blue, tell them what happens to people who fly far and trust their senses.
Yeah. Yeah. What happens, Blue?
You're not going to be around too long.
Was
Yeah.
it 180 seconds or 83 seconds? I forget the number.
It's less than 90 seconds.
So you kiss your ass goodbye first.
Yeah, you
To do
better.
what? Sorry. What's
we
this
could ask John Kennedy, couldn't we?
Yep, John did it. It's one of the classic ways to kill yourself.
What is? Sorry, I missed that. Trusting your senses
John
to do what?
Jr. Kennedy. John.
Yeah.
He flew IFR. He flew VMC, visual into IFR instrument conditions, and crashed his airplane.
It's killed a lot of
I
people.
was at the airport a couple years. I was at the same airport a couple of years after that, so I was asking him around, and they say, "Yeah, he had too much airplane. He had just a basic, daytime visual, whatever, PPL, and he went, and all the other pilots, IMC and not, they were scrubbing, and he went anyway."
Well, the pilots will call that gotta go itis. And it happens way too often.
He augured into the water.
Yeah.
Get there, itis.
Yeah,
And he had two
you
hot
box
chicks with
yourself.
him.
What you never, ever do is box yourself in to the point where you have no choice. You have to fly the airplane. You have no other way of getting where you've got to be, and you've absolutely got to be there. And the only alternative you have is that airplane. That is the most dangerous situation you could ever put yourself in. And that's what happened to him. And his, I don't know if he had his wife and a friend or something which pushed him late, which is what really got to him. He no longer,
'cause he
he
was not
forfeited the
just
option
put
of
off
hopping in the car and driving up there to Martha's Vineyard.
Not only taking off in IMC, but night. You put the two together and over water.
Well,
So you're going to have no ground reference points if you.
Technically, he was not in IMC. Technically, that was not IMC.
What is IMC?
Instrument meteorological conditions.
Oh, okay.
That was technically not IMC, but it was a hazy, low visibility sort of night. And I can tell you that one of the more dangerous.
I think they call it.
Huh?
Yeah, I think they call that marginal BMC.
Yeah, it would be marginal for sure. And I'll tell you that there's something that happens to you at night, and especially along a coastline, because coastlines are covered with lights usually. You know, it's just a continuous string of lights up and down any coastline. When you're not approaching that coastline at 90 degrees to it, it's running off at an angle. It will create the impression in your mind that your wings are banked. Your head will start telling you, oh, well, wait a minute. I need to level the plane. No, you don't. You're flying level. The coastline's running at an angle.
Yeah, at that point, your windshield is not an instrument.
No longer. And it's one of the reasons why the U.S. is one of the few countries that actually allow pilots without an instrument rating to fly after dark. You can't do that just anywhere. I've been in favor for years of eliminating the ability of private pilots to fly at night.
Unless you have an instrument qualification.
Unless you're instrument rated, exactly.
Yeah.
So he wasn't instrument rated. Kennedy wasn't instrument rated then?
No.
Right.
As far as I understood, certainly in the UK, nighttime is classed as a meteorological condition that requires you to have an instrument rating.
It should be.
And in fact, when the Royal Air Force talks about having an all-weather fighter, that means one that can operate at night as well as during the day and in bad weather.
Yeah, I had a friend.
We could just call night bad weather.
Yeah, it is.
I had a friend that flew out of the airport where I had my airplane, and he was just a private pilot. And in fact, I had given him a couple of lessons back when he was in training still, as a stand-in for his flight instructor. But knew the guy pretty well. And we got some new Cessna 172s, and they were the first 172s we had that had a GPS on them. So he left Knoxville and flew over to Asheville, North Carolina. Now that's on the other side of the Smokies from here. You got to fly right over the top of it, and in fact, over the highest part of it. He got over there, he stayed until after dark, and it was a wintertime night, and he started back, did everything properly, except that instead of flying the normal route that we would fly, which was, via some airways and VORs and things, what he decided to do was make use of that spiffy brand new GPS system, which would allow you to punch in GPS direct and just go straight from wherever you are straight to whatever points you want to go to, right? So he punched in GPS direct, and that did take him exactly over the top of the highest point in the Smokies. His last radio call, because he was just he had VFR flight following with ATC, which basically means not much of anything other than they're talking to you. They don't have any responsibility for maintaining your altitude correctly or any of that. He called in and told them that he was beginning his VFR descent into Knoxville, and all we could ever come up with is that from the position where he called ATC and said he was starting his descent, he was seeing the city lights of Knoxville. What he didn't realize was he was only seeing the north half of the city. The south half was blocked by that mountain, and he flew straight in the side of that thing. In fact, they found wreckage scattered on both sides of the ridge line. It was a tragedy. But yeah, that's the sort of thing that happens to you when you are flying at night and don't have an instrument rating. It's very dangerous.
I forgot about sector altitudes, huh?
Hmm?
You forgot about his min sector altitude and stuff.
Well, he's a private pilot. Doesn't know anything about that.
Okay.
Hasn't had the training, and that's what happened to Kennedy too. Well, Kennedy had two things going against him. He had the weather conditions, the nighttime conditions, and he had an airplane that was way more than what he really should have been messing around with. That Piper Saratoga is a hell of an airplane. I love those things, but that's a handful, even for an experienced pilot.
It's like the old doctor killers, they buy a good airplane and it's too much for them.
Yeah, beach bonanza.
Yeah, Blue, I'm still keen on one day when I'm getting myself organised, just you take me on a flight where I'm the pilot or something and you're giving me advice or something going along and a flight from wherever it was, from your place in Microsoft Flight Simulator or something, and you're remotely my guide, and try and do the navigation manually rather than following GPS to see how it goes. Yeah, it's going to be good fun. But yeah, I'll have to get that organised. Because I think you can do that presumably in Flight Simulator, where you can be in the passenger. You can be remotely in the passenger or something, and then you can see me flying or something, and then yeah, it should be. Yes. Anyway, still intent on that plan when I've got all the other things I keep on meaning to do. Do you fly much these days, then, Blue? Or
No, I don't.
Yeah, because you said your training thing had lapsed or something, didn't you?
Yeah, I don't even have a medical right now.
Right.
I figured I cheated death enough times. I don't need to do it anymore.
Yeah, I don't know, Sam Blue, all the things you get up to. Bloody hell, yeah. I mean, and yeah, eventually you're going to get caught out, aren't you? It's a dangerous occupation, isn't it?
It's as dangerous as you want to make it.
I see. So what I don't know if you want to tell me. What's the most silly thing you did then that got you into a bit of trouble? You don't say anything that can be used against you by Bev or anybody.
I never really got in any trouble, to be honest.
Oh, there we go. All right, there we go. There, excellent answer.
Yeah. At least
well, you said you cheated death. You made it sound as though you were, you were fighting hurricanes and you had fighters coming in from left and right, and you were zipping in and out of valleys, and you were doing this, that, and the other.
No, that's another.
Flying underneath pylons and goodness and bridges.
Another pilot saying, yeah. Every time you climb out, you say, okay, cheated death one more time.
Right. Okay.
But we've got about a bazillion silly ass sayings.
Right.
Like anything else, I guess. I've got a lot of hours, a whole shitload of hours. I put 2,000 hours on a Mooney. Just that.
I like how pilots use the word angels for angles.
So pilots, I run into a lot of them that say angels as for elevation. You'll say,
that's the usual thing. Yeah.
Angels is altitude.
Yeah, because that's where your wings are at. Yeah, so we got angel 17.5.
Yeah, that's a Navy thing. Navy's weird.
Okay.
Right.
Still think it's kind of cool.
Well, those Navy guys are weird anyway.
Starboard 3 board.
One of the worst situations I got into was, the problem is I deal with a lot of pilots from the East Coast, and then we would do some projects on the West Coast. So anytime I'm taking a seasoned East Coast pilot, what I call west of the river, they're going to fuck that up. And we were in Mono Lake, which has a field elevation of like 7,800 feet or 7,500 feet. And we took off mid-morning, like maybe 10:30 or 11, already 95 degrees out. And the pilot had no concept of density altitude. And we put that Navajo down the runway. When we came off the runway, the runway just stayed right there in my window. We had no climb.
Wow.
And then Well, I'll give it to this. The pilot was not really aware of the density altitude issue, but she went to raise the gear and the gear handle stuck. Now she's concerned with the gear because you don't get that gear up, you are really fucked. But she would fight with that and then go back to flying the airplane and then readdress the gear and then fly the airplane. And then the gear finally came up. But if we didn't have descending terrain in front of us, it would have been bad. Unfortunately, we had descending terrain. But 95 degrees with a field altitude of 7,500 feet, holy fuck.
Yeah, so that's where I'd like. That's why I'd like to have a more powerful plane. I would have thought it'd be. You have to give yourself some sort of room.
Or you would take off on a cooler.
You fly the plane you got.
Yeah.
Okay.
If you really want to get the gear up quick, you need an aircraft like the old Blackburn Buccaneer with switches in the undercart, so the minute you take the weight off the track. But then it was,
a recipe for disaster. I would hate that.
But yeah, well, it was designed to be fired off the front of an aircraft carrier on a big catapult.
Alan, did you see that? Do you follow Military Aviation Visualized or something channel with a German? And he just went around a Buccaneer.
I watched some of his stuff. Yes.
Right, he went around a Buccaneer last week in the inside.
Yeah, I haven't watched that one yet.
Right.
What's this? Military Aviation Visualized?
Yeah, Military Aviation. He's a German, and he's really good actually. And
I'll have to check that one out.
He's good, and Buccaneer was well liked, I think, wasn't it? It was a very. I mean, it lasted built in the 50s and lasted until the 80s or something. I mean, it's actually used. It was actually used the Desert War, wasn't 90s actually, wasn't it? It's actually
lasted through to mid 90s.
Because it was used for laser designation in the Desert War, and then the tornadoes would light them up, and the tornadoes would then bomb the thing.
And then they realised that because it was designed to self-designate, so they would use it to designate for the tornadoes, but then they started hanging bombs on it as well and dropping the bomb, so it did actually drop bombs during the war as well.
Right.
So, but of course, it was designed as a nuclear naval attack aircraft for nuking an enemy fleet.
Yep.
And there is a clip on YouTube of Buccaneers playing with HMS Liverpool off Gibraltar, and the number 2 Buccaneer goes down the side of the ship just above the weather deck.
Right.
The number 1 Buccaneer is slightly below in front, because you can see the top of the aircraft. So it's literally at the weather deck of a frigate.
Flat sea?
Yeah, dead flat sea.
Right.
Which makes it harder, because apparently that's the hardest sort of surface to fly low over.
What, you lose distance at?
And they're going in excess of 500 knots.
I can make a mess.
Yeah.
I presume, Alan, given your interest in this sort of thing, are you watching the amazing BBC One Rogue SAS Heroes thing on BBC One at the moment?
I don't watch anything on BBC One. I refuse to pay for a TV license.
Oh, okay, all right. You could watch it on iPlayer.
No, because you're contractually required to have a TV license, and if they find out you're watching iPlayer, they'll do you the fine for not having a TV license.
Yeah. Okay. It's just about SAS and parachuting. Did a bit of, in fact, they started up. The guy who started the SAS, which actually was the first sort of major, I think, in the world, the first sort of special unit, and he didn't want to bother to find out how to parachute, so he just got up with a friend and decided to jump out with a parachute out of an aeroplane. And of course, he didn't set it up properly. The parachute caught, torn, and he landed and managed to break his spine almost. And it took him about 3 or 4 months to recover from that. But he was that sort of character, this head of the SAS, who were Americans might not have heard of the SAS, but it's sort of basically a bunch of nutters who go around the world and shoot and kill people to achieve ends, and started off in the Second World War, and they were just amazing nutcases, and we sort of
Well, he
idolise them in this country.
He beat the clock, so that's all that matters.
Major Sterling.
That's it.
Can't remember his first name.
I think it's. Damn it, you've got me now. I did know it.
David Sterling.
I think it was David. Yeah.
Yeah.
Well, look on the bright side. He was the first one to the scene of the accident.
Yeah.
You've never had to parachute, have you, Blue? Have you ever parachuted, Blue?
Hell no.
All right. Okay.
I recently met a former Royal Air Force PTI who was a parachute instructor who survived both chutes not opening.
They were.
I had a minister that did that in Korea. He was a paratroop. And
he landed in the snow or
chute
something?
failed. And he took all the limbs off of one side of a tree. Broke his leg and messed him up, but he survived.
Yeah, I wouldn't parachute. I wouldn't jump out of a perfectly good airplane for no reason.
Oh, it's fun.
Oh, you've done it then, have you, paid?
Yeah, it was fun. I was traveling on space available on the military transport to visit my uncle who was in Germany, and one of the Army guys was he was an airborne trooper. He looked at me. He had only had 25 jumps or something. He noticed that I had my airborne wings. So we sat together and talked on the whole flight over, and fell asleep and talked some more. And as we get to the top, as we start descending, they pull the throttles back and everything starts getting a little quiet, and the plane starts angling down. He gets really nervous. I'm like, what the hell's wrong with you? You've been up in airplanes. He goes, yes, but I've never landed in one.
Yeah.
And I'm going like, okay, this is the easy way. Okay, you don't have to jump out the side. You don't have to do any of that shit. You just like sit here and it lands. Okay, but he'd been up in the airplane like 25 times and then always gone out the side door.
Too scared to land.
You'd never done it before.
Yeah, I don't. Yeah, I've got a bit of a dodgy back, and so the idea of coming from a great height and landing and gnawing my back, it doesn't appeal to me at all.
Well, if you do the civilian way with the double jumps and stuff, where they tie you onto the front of a guy, it's pretty safe.
Oh, yeah.
I never had any particular desire to go do that. I used to fly those guys, though. I'd fly the plane.
Were you wearing a parachute?
Yeah, you betcha.
Yeah, because it get wrapped up sometime.
If I see the pilots putting on parachutes and jumping out the plane, I'd be worried.
Well, how about that, where that CASA, I think it was a CASA, there was a jump plane, and they had a tailgate for the jumpers, and they were doing touch and goes, and they touched and go too hard one time, and the wheel broke off. So they were going to transit to a bigger airport for the emergency landing. And the co-pilot either somehow managed to fall out or jump out of the back.
Yeah, I read this one.
No parachute. They said, "Where's your co-pilot?" He goes, "Well, I'm not real sure. Somebody's backyard."
There's an image I recall of a bunch of people in parachutes getting on the wings or something of an airplane flying along.
Oh, they do weird shit, like in a Twin Otter or something. Yeah, you'll end up with a half a dozen people like climbing out on the gear and struts.
Yeah,
and shit.
Yeah, because they can all let go at the same time and do formations and shit.
And so the poor old pilot, obviously that rather affects the wing dynamics, having all these people on the wings.
But a jump pilot, he's like your worst fucking nightmare, man. He'll do anything. He don't care.
I watched a video last night where they had about 5 guys or 6 guys outside the plane and 4 getting ready to get out of the plane when the plane suddenly lost power and started to stall and dumped out 4 of them, or 5. I guess 6 of them got dumped out. 4 were still in the plane. So they watched the plane as it went down, and eventually the guy got control, and the guys that were remaining in the plane jumped out. By that time, the guys that had jumped out earlier caught up to them, and they still made their formation.
They still made what, sorry?
They still made their formation. They got into this circle formation that they made.
Right.
But can you imagine what's going through your mind as you watch the plane plummeting to the ground? Is he going to make it out of that stall or not?
That's not... all high drama, isn't it? Bloody hell.
I had a pilot a contract pilot for Twin Otter, and he was a jump pilot. And man, I was nearly uncomfortable half the time because at the end of our mapping runs, we'd be coming into the airport. He would nose that puppy down like 4,000 feet a minute, and I like, well, what's your hurry? But he's a jump pilot.
Right.
Oh, he's got to get that plane back in the air in 20 minutes.
Yeah, that's right.
Tow pilots are the same way. The guys that tow the gliders up, they want to get down as fast as they can. They'll do all sorts of weird stuff, slips and stuff to get down. You ever seen the guys in the Gulfstream that did the shuttle approaches? That'll wake you up.
I find being woken up. I've done a few glider flights as well as a small airplane as well, and that the acceleration you get on those things is just amazing. When they pull by a cable, Jesus Christ! One moment you're there, the next moment you seem to be going up at about 90 degrees, and before you can get your second breath, you're seem to be about 500 feet high.
Gliders are great fun.
Yeah.
There was
when you're learning to glide, it's not much fun when the bastard instructor pulls the cable release when you're about 60 feet off the ground.
Oh, so you can do the emergency landing shit?
Just as you're getting it pulled back to get the maximum climb out of it, and the bugger pulls the bloody cable release.
To test you.
And you suddenly instantaneously lose all your motor power.
Yeah.
With the aircraft at far too steep an angle of attack for it to actually fly.
Yeah. But the amazing about gliders is, when I was flying it, I would stall it and not realise it. And the pilot told me, actually, you've just stalled this, and it sort of recovers, because obviously it can, being a glider, of course, it can sort of recover from a stall very quickly. But I was still surprised that I was unaware of the sensation of stalling and then recovering. He informed me that's what I'd done, which was a bit distressing. Someone's chewing. Stop chewing and eating, whoever's chewing and eating.
Yeah, that was nasty.
Yeah, nasty. Yeah.
Yes,
Sorry, I muted.
Or chips, as you might call them.
I'm sorry. I thought I muted.
Okay. Forgiven.
Yeah, it's okay. You're forgiven.
Yeah,
crisp.
Crisp if you're over on the other side of the Atlantic, right?
Yes, crisps over here.
Yeah, well, I call it food that makes for the sound it makes, and not for what it is.
So, Alan, I presume this was a test to test your ability to recover from this experience.
Yeah, well, of course, the thing is that occasionally the cables will break.
Yeah.
Yeah, but weren't you a crash test dummy for one of the gliders there one time, Alan?
No. That was the instructor that was a crash test dummy. Because, when you land really hard, that 1/8-inch ply piece, the top of the wheel box.
Hot mic, Esther.
Yeah, you got a single wheel that's all held in with bungee rubber, and the only reason I didn't put the wheel through the top of the wheel box was the other side of the top of the wheel box is the instructor pilot's seat. So he's securely strapped to it. So of course the wheel didn't go through the top of the box because the instructors are on the correct side. Instructor was not a very happy man. Especially as they
about having skid marks.
I see Gary's in the chat claiming Polaris is 4,000 miles up. That's highly amusing. Yeah.
Well, it says probably 4,000 plus miles above the surface.
Yeah.
Yeah, but it only works at one place. If you move at all, then triangulate again. It's either higher or lower, depending.
Correct. Yeah. I mean, it's just.
Well, I'd agree with him. It's 4,000 plus.
Yeah, the plus part got him.
A lot of plus.
Just got him out of it, didn't it?
A shitload of plus.
That's one big plus. Yeah.
Gary says absolutely 100. It does. Let's see. which is why EQ mounts fail near the horizon.
Oh,
They
EQ mounts don't fail during the
fail,
horizon.
Gary. They don't fail near the horizon. Refraction just messes with it. That's all.
And you can get more expensive ones that have the refraction model built in. But it just gets out of sync by a little bit. But for him, as soon as that happens, it's non-existent. It's not working. It's all wrong. We know nothing. Oh, and the fact that the bottom, it does become kind of oval. The bottom is refracting more than the top. That's how severe it is. Right, but the width stays the same, so it's not getting smaller. Oh no, oh no, oh no, oh no, oh no, oh no. If it's shooting one direction and not the other, that means you're wrong and I'm right.
So there are EQ mounts that actually take into account refraction to keep their.
Yeah, they do. More expensive ones. Yeah, it's called I believe it's called the King King drive.
Yeah,
the computer-driven ones.
Wow.
The computer-driven ones will compensate for it.
Yeah, well, it's all computer-driven, but you buy the less expensive ones. It just runs in sidereal time or solar time or lunar time.
Which is why astronomers generally don't observe below 15 to 20 degrees from the horizon.
Yeah.
That's right.
Although for solar azimuth, I 15 and 20 is just fine. Great. Because refraction is only in the vertical. Horizontally, nothing changes. Nothing.
Yep.
Yeah, it will not affect your azimuth at all.
Not even a little bit.
Not even a little bit.
Right. And the diameter of the sun, the angular diameter of the sun, which is 32 arc minutes, I use a daily value because it does change 1 or 2 arc seconds per day. And I use the same value at noon as when it's just 15 degrees above the horizon. It's the same value, the same angular width. Didn't get any freaking smaller.
How much does it change? How much does it change over a year?
Over a year? Well, over 6 months, it changes 1 arc minute.
Okay, that's right. 6 months, 1 arc minute.
Yeah, from aphelion to perihelion, 1 arc minute. And so you're not going to get something episodic across any one day. At equinox, that's when it's changing most rapidly. That's when you'll have 5, 10, 15, could be 10, 15 seconds for a short period, and then it slows down as you approach solstice.
Gary says the EQ does not accurately track anything at 15 degrees per hour from horizon to horizon. No, it'll do better than that, Gary. In fact, you ought to watch some of Wolfie's stuff. He did one time where he let it run all the way through the night. And the telescope was pointed straight down at the ground around midnight. And the next morning, by the time the sun came up, the telescope was tracking the sun again perfectly. So, yeah, it actually does do exactly what it should do.
Maybe Gary is talking about his EQ mount. Maybe his EQ mount doesn't work. You know what? I'll bet that's it. He has a bad EQ mount, or he doesn't know how to align it. Or maybe Gary doesn't have an EQ mount. Wait, maybe Gary doesn't really have anything in the way of a telescope. I've seen his survey instrument, carpenter's file, and a piece of PVC pipe. Yeah, I've seen that. So obviously he is an expert on the EQ mount.
More importantly, I wonder how Wolfie aligns his EQ mount in the southern hemisphere. How's that
to
work?
The poles. Yeah, he aligns it to the poles. It's no fucking different.
I know.
You're full of shit, Gary.
I've done it in the southern hemisphere also.
You're full of shit, Gary. He showed Wolfie very well did show it tracking the sun.
He sure did. Hey guys, can you hear me?
Yeah.
Yep.
Oh, cool. I just got a new EQ mount, and I'm only going through the instructions now. I'm using it for the next solar eclipse, and it most definitely this one adjusts for the refraction. And according to the specs, it is a minute adjustment. You know,
Yeah,
it can easily be disregarded and still maintain the subject in frame.
Yeah, Gary just makes up stuff. He doesn't have any equipment. He doesn't use any equipment. He's never seen any equipment. He's heard some people say, "Oh yeah, near the horizon, they'll get out of sync because the rate of vertical angle change is slowing." All right, when it's near the horizon, only near the horizon. Okay, there you go. So what? And EQ mounts, you go back, 10 years, they were all just simple clock drives. Well, now, yeah, they're all microprocessor driven. So yeah, it's done. But no, Gary just makes these assertions. He has no experience touching, seeing, operating the equipment.
Gary's only lying to himself at this point. Nobody else believes him.
Well, Gary's got rubber bands on a board with thumbtacks, so he knows better.
Who can top that?
Yeah, but those bands are color coded. Don't forget.
Well, I kind of like the rubber bands. I think you could probably play Foggy Mountain Breakdown on that thing if you wanted to.
He was also saying earlier that no pilot allows for Coriolis. And of course, it's no matter how many times you tell people like him, you don't have to. But it's just.
Well, that's true. You don't, but you do, but you don't think about it, basically.
Yeah, because you just do waypoints or whatever, and you just don't need it. The effect is tiny. I don't know how many times you have to tell these people. For an aeroplane going along the speeds they do, you don't have to allow for it.
Well, there is no Coriolis meter in the airplane. I'll give them that.
It's just.
I got to dip out, guys. Later.
Yeah, see you, Sean.
So.
If they understand, I mean, I don't. It's all part of this flat Earth reset. You explain something to them in a convincing and compelling way, like saying that the Coriolis effect is less important than a waft of wind or breeze or something. Much less important than a waft of wind, or waft of. Anyway, and then they seem to sometimes take that on board, but then of course they have the classic flat Earth reset. The next day they forget you've informed them of something useful. It hasn't lodged in their brain, and they go flat Earth reset, and they go back to their preferred delusion.
It's only one way with flat earthers. It's all out, not in.
Is what, sorry?
With flat earthers, it's all out, not in. It's always outward projections and statements and opinions, but nothing comes back the other way to them.
Yeah, they can't absorb information. The trouble is, they don't listen for a start, as you say. Then if they did listen, they don't understand it. And if they do understand it, then they don't store it. And if they do store it, they can't retrieve it. So there's a whole sequence of things they can't do that prevent them from ever learning anything useful.
There's a name for this series of events. It's called a learning disability.
Well, they're all low IQ types, even though we talked before about people like Dr. John D.
The thing about it is Coriolis is important to a pilot because it is the major driving of the winds in the world. The winds that go from west to east across the United States and Europe are Coriolis based. So.
Yeah, but they're all in different directions, aren't they? So it's not as though there's some. It depends on what the weather systems.
Oh, the prevailing winds, though, are west to east across the United States and most of Europe.
Though that's.
Most of the weather systems in the United States move from west to east, and they do the same in Europe.
Yeah, indeed, but that's not Coriolis as such. That's just the way they spin after it, because Coriolis can only have an effect on something moving relative to the reference frame, the rotating reference frame, and so it's an effect upon that. So the prevailing wind gets you moving, and then the Coriolis will affect the way that changes. Turns it into circulating depression.
Because the equator's higher than the poles, so the winds flow toward the poles, and they're bent by the Coriolis force.
Yeah.
It's the jet stream, and
right. The jet stream also flows. The jet stream is Coriolis because it's flowing eastbound. It flows the same.
Jet stream wiggles up and down.
Right, but generally the general direction is west to east.
Yes, but that's not due to Coriolis.
actually it is, but okay.
I don't think it is. Well, okay. Well,
Yes,
that
it's whenever the warmer winds is actually attracted towards the poles.
yeah,
It's
but
going to
that's not
deflect to the
Coriolis.
east. Well, it's going to deflect to the. It's going to deflect to the east or to the right because of Coriolis. It's not going to go straight to the pole. It's going to be deflected to the right as it's going northward, and that's what causes the jet stream to travel that direction. Is because the Coriolis is causing the warmer air that's going towards the poles to deflect to the right.
Yeah, to make the Coriolis effect causes things to go in circles.
No,
that's what Coriolis. Yes, it does. Very different.
Well, it depends on how far it goes, and the jet stream is actually going in a circle. It goes in a circle all the way around the Earth.
No, not that sort of circle. It makes it deflect anti-clockwise or clockwise. The Coriolis effect causes that, depending on your velocity. If you're going north to south, then it will cause it to go
to the right. It's causing to deflect to the right, no matter what in the northern hemisphere.
But it will keep on going to the right. It will, because the Coriolis force is always perpendicular to the direction that the velocity direction. So the velocity component will always be changed by the Coriolis force 90 degrees to what the velocity is.
Right.
So it's a cross product.
As the hot air goes north, it rises. It's actually going north. It's being deflected to the right. As it gets to where it's meeting the cold air, it actually starts cooling off and actually goes down and actually goes towards the ground as more hot air is going north. That you're constantly getting a rotation of hot air going to the north and being deflected to the right, getting cooled off, dropping to the ground, and circling around and going back towards the south again. And you get this rotation like that from high to low, from the hot and cold, but it's always being deflected to the right. And whenever the cool air is actually going to the ground and going back south, that's also deflected to the right, which is going the opposite direction.
Yes, and it's a height. But the thing to understand is the Coriolis effect always acts is the cross product between your velocity and the
rotation vector
and the rotation axis. Yeah. The omega, which is a point that goes through the axis of the Earth. The angle, and that.
That's exactly why when you're at the equator, traveling north or south, there is no Coriolis force. It's zero because the cross product of the velocity and the rotation they're parallel with each other. There's no angle.
Yeah, correct. And the reason you do acquire so in fact, although we talk about, so you'll often see people describe the Coriolis force as if you're shooting up north. If you're firing a bullet or something north, if it didn't descend, it would not actually be affected by the Coriolis force, because the cross product would be zero. So obviously, Dr. Bob would talk about the firing north, but in fact, Dr. Bob doesn't understand Coriolis. Unfortunately, he didn't understand that you get Coriolis forces when you fire east to west. You can also get Coriolis because the cross product. Oh, it's all very complicated. But if you fired a bullet and it didn't descend, you would have no Coriolis force acting on it. If you fired at the equator firing north and there was no descent,
right,
then
you'd be running parallel with the rotation.
Yes, with the axis. Yes, and there would be no Coriolis force.
Right.
So you mustn't get confused between the prevailing winds, which gets you your velocity in the first place. If the wind was completely stationary, there would be no Coriolis force. So if all the air remained stationary with respect to the surface of the Earth, there would be no Coriolis force at all. So that's an important thing to understand. You have to have a velocity with respect to the rotating reference frame. So the prevailing wind gives you that velocity, and then the Coriolis force, which is a force, like someone was complaining in the chat, I think it was a flat earther, saying that he thinks its Coriolis force behaves like a force. Yes, that's exactly how it's a fictitious force, but a force nonetheless. Behaves like one. Looks like, if you remember that video of someone throwing a ball across a rotating room, the ball appears to just shoot off to the right because the room's rotating, and from your point of view, it looks and behaves exactly like a force, even though the ball is going in a straight line. And the same thing happens on the surface of the Earth. and I forgot now where I was going with this. But anyway, the point is, you need mustn't get confused between the prevail. And this is what Nathan Oakley does when he talks about the 15 degrees per hour. He gets confused between that and Coriolis, and you mustn't get confused between the velocity of your movement and the Coriolis force, which acts as a cross product of that with the axis of rotation. But then you've got, as who was it? IB was describing this. Then you've got these issues on foot that are acting on wind, going as it sinks and gets cooler. Then you get other, the cross product becomes more complicated. Then obviously, if the wind is not, traveling parallel to the surface of the Earth.
Where's the trigger?
We couldn't hear what you said, IB.
Sorry, that was my son. No,
right.
on the hot side, on the bottom side, you don't have a low altitude jet stream because you have ground objects that actually disrupt the flow of air. But it's in the rotating reference frame, it's still an inertial force, so it actually retains the velocity of the lower latitudes. So it's going to be traveling towards the east or faster than the air in the northern latitudes. And if your air at the lower latitudes is actually traveling towards the north, it's actually for the, like in a hurricane, it's a low pressure system. So the air is actually going towards the low pressure.
Yeah.
And that's going to make it deflect towards the west or towards the the left. I'm sorry.
The left's right. There's never people. This is what people don't understand the corridors. They talk about it deflecting west or east. It doesn't. It always deflects to the right or to the left.
Right.
It's either right or left. It's always relative. That's why things go around in circles. Why weather systems go around in circles. So they're always a force. And people don't understand corridors. Don't understand why when it's going east to west, it then goes south, because it's always deflecting to the right of wherever it is, depending on the angle of where it happens to be. Because oh god, it gets complicated with. That's why you get the maximum Coriolis effect on the wind anyway at about 45 degrees. That's why you don't get weather systems rotating on the equator or at the poles. You get it in the mid latitudes because the Coriolis effect.
The difference between the jet stream and a hurricane is the wind is actually going towards a point, not towards an entire line. You have the wind going towards an entire line. There's a temperature separation between hot air and cool air around the entire Earth. And it's going towards a line, not towards a point. You're going to have a rotation as it goes towards a point. If you have a line across, it's just going to deflect, and actually, whenever it mixes, it's going to drop. You're going to have the temperature drop, and it's actually going to make the air drop to the ground, towards the ground.
Yeah, I mean, you're talking about more complicated things than I can cope with, where you're talking about individual changes of direction due to other things than the sort of rotational. I'm gonna have to do a video on this. Yeah, so that gets yes, and when it gets jet streamy, and because the Coriolis force only acts on the velocity, the cross product, the velocity you're going a particular direction you're going with the axis of rotation, and obviously if you have effects that cause the velocity to go down or up, because you get the Ellipsoid effect, of course, is a Coriolis force, just the component in the vertical. So obviously, if your underlying velocity is up, down, or left, or north or south, then you just need to do a cross product with that with the axis of rotation.
Yeah, but the Ellipsoid effect is mainly going to be affected by your traveling within the direction of rotation, not parallel to the axis of rotation.
Right. In the direction of or opposed to.
Right. It's fairly common formulas that's used for doing the same thing for ballistic calculations.
Yeah.
Yes, that's subject to the Coriolis effect, yeah.
And it has to do with amount of time and distance it actually travels. And-
Yes, because there's something called the length. It's actually the amount of deflection is. So, for instance, if you imagine a laser, if you imagine a very, very fast artillery shell, for instance, then the effect would be quite small because you might have a bigger force acting on it. In effect, because I said about the cross product between. So you might think that a very fast shell might affect more, but the actual deflection, acts like a force, and if it's got a very short amount of time to affect the shell, then actually it doesn't deflect it very much, even if your velocity is increased. Because obviously the bigger the velocity, that's going to mean that the force is bigger. But if it's so fast, the duration of this force acts is so small, then it's not going to have much of an effect. So it's actually, there's a thing called the something length, which actually determines how much of a deflection it is. And so basically you want something that's going quite fast, but doing it for a long time, which is exactly what weather systems do, that get the maximum effect. Yeah, I'm going to have to do a video on this one day. And obviously we've got tables and things for how to allow for it with artillery shells over distances of a few tens of miles.
Yeah, there's formulas for calculating that out. It's it's not a complicated formula.
Yeah.
You think so? Because it's affecting it all, because it's always affecting a force to the right. You're actually changing the vector, the direction, and therefore, unless that's a very small, I suppose if it's only got, because it's not as though you can say it's going in this direction, and then for the duration of the flight, the Coriolis force is pointing in this way. Because if it changes the direction, it's changing the velocity, which then changes the angle of the, and that's why things go around in spiral. Is that Alan shouting at somebody?
I was just going to say, you do have to really use artillery rather than small arms for sensible Coriolis values. Because if you're going to use small arms, you have to be doing it at stupidly long ranges. Because at 1,000 yards, with your average 30 caliber round, time of flight sort of 2.5 seconds.
Yeah.
And for shooting at 50 degrees north, and shooting in a generally northerly direction as well at 1,000 yards, your Coriolis deflection is about 75 millimeters, about 3 inches, which is just about one click on your sights.
Yeah.
In conditions where, which is one click is a quarter of a minute of arc, and you're talking in conditions where the wind is usually at least 10 minutes of arc.
You broke up a bit there, Alan.
Sorry, you're talking about conditions where, so Coriolis about a quarter of a minute of arc. The wind effects on the same range, on a good day, 5 to 10 minutes of arc. On a bad day, 30 minutes of arc.
Yeah. Do you not work in milliradians then, Alan?
The military snipers work in milliradians. The Continentals work in milliradians, but shooters from the English-speaking world generally, so us and most of the Commonwealth, still use minutes of arc, and the Americans, of course.
But we have the milliradian scopes where we have we do have milliradian scopes where we have the reticles in milliradians, and just recently they started doing the turrets in milliradians also. what used to be the problem was they had the reticles in milliradians, and the turrets were in minutes of angle.
Yep.
Which was really stupid. But
Yeah.
I get all of mine now with either MOA or MRAD on both, to where they match.
Yeah.
But if you really want to get crazy with your calculations, you could actually start adding into the cross component of the Coriolis cross component, and do the drag coefficients based off of your ballistic coefficient on the cross component of the Coriolis 2, and see how much that would actually slow down and actually reduce the amount of Coriolis just from the drag force of the cross component. So it can get, it doesn't have to be, and it's really not going to make enough difference to where you'll notice unless you're doing some really long range artillery. But
well, I'm sure the 105 millimeter howitzer firing solutions, which are all completely, computer driven. Yeah, they have all kinds of input, and that's why they're talking about being able to hit individual buildings at 25 miles.
Right. But you're not going to do that with your sniper rifle at 1,600
We're
yards.
talking about Coriolis and marksmanship with a rifle. That's like, measuring the shape of the earth from a 1 foot observer. Come on.
Yeah, the problem with this whole conversation is it's not even the right question to be asking. It's driven by the idiotic flirts that don't have any idea what any of this means. The real question is not whether there's Coriolis or not. The question is whether or not the Earth is rotating. If it is rotating, Coriolis is unavoidable. It has to be present. It cannot not be. Coriolis is very real. We have to take it into account with all kinds of rotating equipment. It's an actual real force that occurs. Talk to people that design helicopter rotors. There's a problem with it.
Yeah, and since we experienced Coriolis in so many different disciplines, that's a demonstration of the rotation of the Earth. And then we got tides, and then we got then we got starts. So the rotation of the Earth is not up for debate. Really, the shape of the Earth is not up for debate. It's just the question of why do they say trust your senses and you're in denial, and yet they deny the South Pole. I give up.
Well, there's so many other ways that you can show the rotation of the Earth. You don't need Coriolis to do that.
I know, and that's why the British,
force.
Yeah, that's why the British flirps like Mavitt and crap. They kill me because they're right down the street from Greenwich Observatory. I'm like, hello.
Hey, shout out to the Stingray for 5 pounds. He says, please go easy on flat Earth. They're like the special kids that need help while thinking they're all geniuses. They really do need our sympathy.
Yeah, they're all members of the short. Yep. They all ride in the short bus for sure.
No, they don't get on a bus at all.
Well, the short bus, the one that takes them to special.
No, they stay home. No,
hey,
homeschool.
Careful, I have to get on the short bus these days. It's the only way I can get anywhere in my bloody wheelchair.
I don't mean that. I'm sorry.
Yeah, I was going to ask if it was a short bus with a lift gate.
Oh, yes, it's definitely a short bus with a lift gate.
Well, United States, the short bus refers to the fact that the people and kids on special ed get special pickup and drop, and they use a shorter bus since they have fewer kids. So.
Good evening.
It's very similar over here, to be honest. Don't worry.
Good evening, people.
Hello.
Good evening. How are you?
Has anybody managed to teach Bev 8th grade geometry yet?
No.
Still working on first grade addition and subtraction.
Yeah, no was both a short and long answer.
Has Bev made Has Bev made any comment on Blue's last vid?
Oh yeah, he spent all damn night talking about it.
Oh yeah. So a little nostalgia lane. So I remember my it was 8th grade. My geometry teacher explaining to us exactly why the intersection of two curves can be thought of as an angle, and teaching us, that geometric. He explained it as if you zoom in infinitely, then they just become straight lines. But that was his explanation, that they are of course the definition is a tangent to the curve at the point of intersection.
Yeah, the tangent of each curve.
Yeah, and I learned this in 8th grade.
I know, they're idiots. Okay, that's all there is to it. And Bev is particularly insistent on being proud of his denial of observation and 8th grade maths. And yet he says, oh, he has some little surveyor certificate from his A levels or something.
I think he's got a religion built up around Euclid. I think he believes.
No, it's vocabulary. He picked up on a piece of vocabulary. It makes him sound erudite in his own mind, and therefore he repeats it all the time.
Okay, that's another interpretation.
And
sure.
he cherry-picked Euclid at that, because there are parts of Euclid that he doesn't like the fact that the surface of a sphere is two-dimensional. He doesn't like that.
He also doesn't like the fact that Euclid never defines what horizontal is, does he? Does he?
I don't think so.
He does. I don't think Euclid does.
There is another
with
work where he defines the horizon to be a circle, which is a cross section of a sphere. So
cool.
That's fun.
Oh yeah, that's right. Well, I think maybe Euclid does define horizontal, but he doesn't define horizon, because that's an astronomical term, horizon, or geography term, right?
Well, no, he does in another publication, not in Elements, specify that the horizon is a circle, because if you cut a sphere, that's what you get. A circle.
Okay.
Yeah, when they talk about not seeing any curve left or right, well, if you look out of the ocean and the horizon may be some 5 miles distant, when you look hard left, it's still 5 miles distant. And when you look right at the bisector of that, it's 5 miles distant. Everywhere you look, it's 5 miles distant.
By the way, I'm wondering if Doofus, are you wearing a neck brace? Because the last time with the people in that other Discord, I think you probably suffered whiplash several times.
Well, it's a head turner a lot. I mean, Demok for sure, but Sin Cleanser. Sin Cleanser was so confident in his optics quote knowledge, and it took me only one question to find out that he could not give an answer.
I don't know. I still think that the magnetism thing is the key to that one.
That was fucking amazing. I could not believe that.
They both start off magna, so they mean the same thing.
Regarding that horizon, about 5 million years ago, I was talking to a flat earther about the horizon on the ocean. I forget his name. Brenda would remember. And he was under the impression, he said, well, when you look straight out, it's what, 3 miles? I was like, yeah, sure. And then when you look to the side, it's what? You add how many miles? And for the life of me, I had no idea what he's talking about, because I was still a little new to flat Earth. I realized he thought the horizon was a straight line.
I don't remember who that was, but I sort of vaguely remember that. Yes, they think it's a straight horizontal line. Yes, they do.
Yeah, they think it's the horizon is perpendicular to their line of sight.
Yeah,
right.
And instead, as I said a second ago, it's 5 miles straight ahead. When you look to the left, it's 5 miles, and when you look to the right, it's still 5 miles, which is the definition of an arc. Yeah, and that's why you don't see left or right curvature.
And imagine how they always sent the lookout to the top of the mast, because you could see further.
Oh,
I had some additional conversations today. I was told that a sextant cannot function without a horizontal baseline. I gave them a direct counterexample in which you measure two landmarks, the angle between two landmarks, where there's no horizontal reference at all. And they proceeded to block me because, of course, they can't handle being wrong.
That's the Oakley narrative. That's the Oakley narrative.
Yeah. They have no idea that if you turn a sextant on its side, holding the arc, level instead of vertical, you can. Then it's just a protractor. But when you hold it vertically, it's just a protractor.
Well, the way to get that is you'd ask them, well, what does the sextant measure? And it only measures angles. That's all the damn thing does. It measures angles.
Specifically, it measures the angular separation between 2 points that you can see.
Correct.
Yeah, but Nathan Oakley's narrative is that you have to have a baseline to measure an angle of elevation. That's his narrative.
I mean, hold on. You stopped with saying Nathan Oakley. You saw you can just.
Yeah.
Well, okay, when you state it's an angle of elevation, now you are referencing it to vertical, which is gravity, which is the plumb bob, which is why when you're using either the theodolite or the sextant with a pan of water, you don't have a dip correction. You look to the ocean horizon, now you got a dip correction. And the horizon is not a point of reference for anybody except a marine sextant in a marine environment. You don't see a carpenter needing an ocean horizon to level a table.
Right. And they told me that with a marine sextant, since the horizon is one of those reference points, that has to be horizontal. And I told them, well, no. If you had actually done any celestial navigation yourself, you would know that the horizon's kind of a poor choice for a horizontal reference if you have any altitude, because you have to correct for the amount that it is dipped below horizontal. And they were like, no, it doesn't do that. It doesn't dip below horizontal. They're stuck on Dubé.
Where's the horizontal baseline when you're measuring the angle between stars?
Yeah, I don't know.
Yeah, exactly. They have no experience using one, and therefore they are expert and can call the experts wrong when they teach it, as well as independent people teaching it, every manufacturer having manuals on it, entire semesters of cap seamanship are on celestial navigation, or at least were pre-GPS. Yeah.
Which is, your thing about the horizon is the higher you go, the worse it gets, which is why airplanes, when they use sextants, were using bubble sextants to determine the horizontal a different way, easier way.
Well, because quite often, because they're quick with a bubble sextant because they're going to have clouds so often. Yeah, once you go one way, you stay that way.
And when you get high, the correction to the horizon becomes really, really tough. Huh.
And you're looking at the sextant through the bubble canopy in the top of the plane. So you'll never have the opportunity to turn with a marine sextant to an ocean horizon.
They tried it at the beginning and it worked sometimes, but it was not, which is why they developed the bubble sextant. Then they developed periscopic sextants, so you didn't have to have bubbles sticking out of your airplane.
And all of that is just for the convenience of where you're at.
Correct.
But you can still see those plexiglass bubbles on older airplanes.
Right. Yeah, they generally stopped somewhere in the 50s. I think they started doing. Once they started going in jets, basically, the bubble was too big a drag.
Once they came up with a gyro compass.
They still had a sextant on on early 747s. It was just they had a fancy periscope system for seeing out the top.
Yeah, that was pre-GPS, 1968, 1970, or something like that. And they needed a backup. They needed a plan B.
Yeah.
By the way, if you take a long stick and you stick it into the water, it will come out the other side of the earth. I could not believe that.
So all the flirs ready to go look at the.
Wait. Someone actually said that?
That was Democ.
Oh, Democ. Well,
of course.
I don't have a problem with that because if you take a long enough stick and push it down, you'll come up with the antipode on the other side. That's okay. Yeah, you can't have a stick that long, but if in description, if you drew your globe on a piece of paper and you took your straight edge and drew your long stick,
Yeah, and you got that problem with that solid iron core in the middle.
I know it's mechanically impossible, but it's descriptive.
Yeah, it's very descriptive. It's a really useful thing to think about.
Well, I think he was talking about just. I'm sorry.
Yeah, it's called the North and South Pole, the axis of rotation.
Here's a question. In theory, would that stick be weightless?
No, because if it's one long continuous stick, it would still be affected by gravity. But if you had a borehole that went through the Earth and you dropped something and you put something at the center of the Earth, then that would be weightless.
Oh, Earth is life. Earth is life. You had a great interaction with Bev. What was it? Several days ago, 2 or 3 days ago. I don't remember exactly.
I jumped in there just to.
That was excellent. That was excellent. That was excellent.
Yeah, I wanted to go in there and troll him a little bit, so I was feeling trolly.
Hey, Guy, just as Gary decided he would actually come and visit us, do you think we should actually stop and let him say something?
He's not going to say nothing.
Yeah, I was just biding my time.
Oh, there he is. Go ahead, Gary. Tell us about narrow angles and the Rayleigh criterion.
Well, I want to talk about the bubble sextant at the moment. So.
You've used a bubble. You've used a bubble sextant before?
No. But I'm going to ask these guys a few questions. So
have you used a sextant? Have you used a sextant?
You're looking to. If all you're doing is looking to make a smart remark, B-ball, then you're not welcome to talk to me.
A protractor and a straw. Have you used that?
Okay, I'm asking somebody about a bubble sextant. What are you measuring to on the bubble sextant?
A level.
So your angle to the bubble sextant is your baseline, right?
Yeah,
I'm not sure what they look like, but you got a vertical angle to. It's not to the horizon; it's to the bubble sextant, right?
Correct.
And you measure the bubble sextant,
which is why the perspective will remain the same because it's a perspective angle. That's why you can take the bubble sextant, you can use it on the ground or you can use it at 10,000 feet. You get the same angle to the sun or a star.
Right.
That's correct.
Right.
But
because
you actually on
the reference to the gravity vector, the plumb, the vertical doesn't change by altitude. So vertical is always vertical.
But if you took a regular sextant and you went from ground level to 10,000 feet, you would get a different elevation angle to the horizon, right?
And a bigger dip angle to accommodate it.
No. We're not talking about that. We're just talking. You get a different. I know you, but you'd get a different elevation angle, correct?
Correct, because you're higher. The dip angle would increase, which is why they went to bubble.
The horizon would go off further into the distance, still at
the horizon drops.
It's under your eye level, but virtually indistinguishable. But whatever's in the sky, like the sun or Polaris, it moves up in your field of view.
Okay, if you used a marine sextant at 10,000 feet. And you measured to the horizon, you did not get a vertical angle, you got an angle to the horizon. And you want the vertical angle, then you calculate the dip, and then you subtract that from what you read on your sextant, and then you have the same vertical angle as if you had a bubble sextant.
All you're doing is adjusting it back to making it a perspective angle that you see on the ground at sea level.
No,
yes,
because the bubble sextant, listen to me clearly. The bubble sextant, you measure directly your angle from vertical to the object you're measuring. You don't have to skip on the marine sextant.
The object you're measuring is what you're measuring at the vertical.
No.
Yes.
You don't measure stuff directly above you because you can't draw a circle of equal altitude. Because if you happen to the star happens to be directly over you, that's not a good place to move to. You want to be off the horizon. You want to be off the vertical. So on a bubble sextant, you measure that angle directly. On a marine sextant, you have to calculate that angle because it comes out. You measure the. It's like the result
because
3 or 4. However,
but the bubble sextant on the ground would measure the same angle because you're taking your perspective to the baseline of the bubble sextant.
Listen to me again. Then the bubble sextant, you measure the vertical angle, the angle from vertical to the object you're measuring directly. That is.
So you're measuring from directly above you, no matter what's up there, to the star, right?
That's correct.
Okay, well, that you still get to end up with the same thing.
That's correct. On the marine sextant, that is the result of several calculations. So the bubble sextant, you just measure it directly, so you can skip a few steps, if you will.
Yeah, you're just measuring an angle in the sky then.
That's correct. That's all that the sextant ever does is measure an angle.
And so then you take that's why you can take the distance with the bubble sextant, whether you're on the ground or in the sky.
Stop.
10,000 feet up. You're going to get the same measure, and you're going to get the same angle that you would get if you took it from the ground with a regular sextant.
A sextant does not measure distance. A sextant measures
angle. Sure it can. If you measure the angle to directly above you, right, straight up 90 degrees, and then you measured an angle to Polaris, let's say, you can take that angle and you can adjust that, or you can get the distance to that point where it's GP is.
Eventually.
How do you get that, Gary?
But you don't measure. The sextant measures angles.
Walk me through the process, Gary. Tell me how you get that distance.
Well, you would measure the angle to the sextant, and then you would see it goes 90 above. So if I measure it at 30, I would take the 60, and the 60 is the distance to the GP of that star.
So 60 is the distance to the GP.
If you're taking the angle directly overhead, then the other angle goes to the star. Then you would take that direct measurement times 69 miles per degree, right?
It's a globe.
And you would get your distance to the GP of that star.
No, you get a circle of equal altitude.
Have I got it drawn out in a diagram here pretty well here, though?
Yeah, pretty much. It's been a long time since I looked through one, but.
Yeah, because we had this discussion with Gary before, and this is back from, I believe, March that these diagrams come from. So we've had this discussion, Gary.
But Gary did cite the correct thing when, yes, if you measure the angle from zenith to Polaris.
I'm going to disconnect that. You guys are.
That is your distance. That is the distance.
I can't understand a word you're saying. I'm going to disconnect and reconnect.
He's doing a reset right in front of us.
Yeah, see the sextant angle that's above you, Doofus, that's the marine sextant, and you calculate the zenith angle. It's like the result of, after you get all your corrections and everything, you calculate the zenith angle. On a bubble sextant, you measure it directly.
Yeah, it's still going to return figures as if you're getting a vertical angle, but I mean, it's doing the math for you essentially at that point.
If you do it correctly, a bubble sextant and a marine sextant will yield the same results.
Yeah.
They should.
Yeah, the original question though was malformed. It's like it's not measuring. He said they using the sextant to measure to something. It's measuring between things.
That's right.
Sextant measure angles, and this is something that flat earthers get wrong because I don't know, because they mess up the calculations later on. First of all, most of them have never touched a sextant in their life.
Also, why a sextant? You can use, there's a host of other instruments to measure distances.
Well, the reason that you use a marine sextant is because back in the day they didn't have GPS or any of this other stuff, and it was actually quite accurate. A well-trained operator, a good operator, good sextant, could get your position. This page is
everybody was roboting a minute ago. That's why I hung up. I'm back.
Welcome back. Is Page a super flurf? Is that Page?
Yeah.
Oh God.
Yep, she's going all off on water levels are horizontals. No, they're giving you equal altitudes.
Paige, you
She
live
got
in
all sorts of problems.
Australia, for Christ's sake. Look south at nighttime. Southern Hemisphere flirts are among the dumbest of people. So, Gary, if you're so good on the sextant, why haven't you claimed MC Tunes $10,000?
That's a good question. Why hasn't anybody claimed it?
Yeah, because you have to use the angles you take are perspective angles, and you would have to use an almanac just like you guys use an almanac. It's just a perspective angle when you're taking elevation angles to the stars or the sun. And he won't allow the use of that.
That's not correct.
Now your angles are really just perspective angles, and they're based on your field of view. So those change. Go up, it changes. If you move away or go towards, it changes, right? Or down, it changes.
That's
because it's based on your field of view, and your field of view as you move away is perspective being compressed. That's why everything in the sky will move down toward. If you start moving away from things far away, you move away, and everything starts compressing down towards your eye level. If you go towards, everything starts moving up from your eye level, or down if it's below you, or from the sides to the outward.
And MC Toon did revise his rules and said, yeah, you can use ephemeris. And my question,
yeah, but then he wants an explanation though of why our elevation angles aren't what you would think with trigonometry. But the reason that's not is because your field of view is based on where you're at. Not trigonometry for measuring the distance Polaris is only good if you can actually see the base, the GP point. Once you move past that and it's out of your range, it's your line of sight to Polaris, to your optical horizon, is completely different. And so that's why you move away, and you're going to get a lower and lower elevation, what you think the height of Polaris above the Earth is, because your perspective is compressing as you move away.
Well, that's awfully convenient for you, Gary, because
that's how it works.
You can't have that's awfully convenient for you, Gary, because you can't have vision on the GP and have Polaris been deflected from zenith by more than 1 degree. That's impossible.
No, because your field of view is going to compress as you move away from Polaris. And so it's not only that, but that space, because you can't see the whole visual space anymore. That visual space between the ground and Polaris is also going to compress. Right? So that's compressing, and your field of view is compressing simultaneously. And so that's the part that you're not accounting for. Instead, you call it curvature and refraction. And that's how it got changed. It became curvature and refraction rather than perspective compression.
Oh, by the way,
but everything beyond the first degree of change from zenith, the other 89 degrees where you cannot see the GP, you have no means of calculating your distance to that GP using actual perspective. You say 60 nautical miles per degree.
Well, not yet, but somebody who's mathematically inclined will figure it out.
No, they won't.
Oh,
yes, they will.
Can I just
rules?
Something?
That's not the rules of perspective. This is happening. This is really happening right here. All right, let's try this again. 60 nautical miles per degree is not any rule of perspective. There is no definition of perspective that would allow you to use that math.
Yeah, because as you move away, just like if you drive down the road, you ever drive down the road at night and you notice how the road just opens up in front of you, right? But the lane that you're in looks like it's closing in on distance, just like a railroad track, right? But it just steadily, at a perfectly even pace, because it's linear. It works. Your perspective is a linear thing.
Gary, stop
and that's why the sky and everything will move out to the sides. Everything will move below you and above you at an even pace. And that's why perspective will work perfectly.
Do your eyes work? Do your eyes work the same as our eyes? I'm not sure they do.
Yeah, I just don't think you actually pay attention.
Stop using the word perspective, Gary. You do not understand what it bloody well means.
Perspective is based, first of all, it starts with your field of view, which is based on your elevation over the surface.
Lemon optics.
That is the start of how it is. That's why you go higher, you see further to the horizon. It's got more depth and distance to that point when you go up higher, which works perfectly with perspective.
So again, Gary, why haven't
you have angles subtended to your eyes from all objects in that field of view that places them in their proper place.
God, that's
how do you explain mathematically
why
if you're standing on a railroad track? I'm asking you right now. I'm going to give you a mathematical thing to figure out and show me the equations for. You're standing on a railroad track looking down. Now it appears to slant upwards because of perspective, right? Not actually slanting upwards. And the rails appear to slant inwards. Give me the math for that.
What's the formula? Definition of perspective?
Why does the railroad tracks seem like they're slanting upward towards the horizon and also closing into each other? They appear to be merging, even though they're not actually.
They don't go up beyond the horizon.
And the ground isn't slanting up. But it appears in your vision. You'll see them in the distance, in the center of your vision.
All right, the actual definition of perspective.
Give me the math for that.
I will if you actually allow somebody to.
Okay,
now, the actual definition of perspective is, oh, for fuck's sake, Gary. So the actual definition of perspective says that as objects recede into the distance, their angular size shrinks by an inverse proportion with respect to that distance. That's actually in the rigorous definition of perspective. I've used that definition of perspective in order to create a 3D renderer, which does work. Now, if you have a different version of perspective, I would like your math. So I could implement a 3D renderer that works off of your idea of how perspective works. That would.
So you did all that. You didn't give me any mathematical equations. Why do the tracks appear to slant inward?
I definitely gave you one, Gary. Don't lie to the audience now.
What was your math equation? You didn't give me one.
Inverse square, dude.
No, that's not an equation. That's just an idea. That's not an equation. You can't give an equation for it.
Of that distance. Yes, it's mathematics said in words, Gary.
Why does it appear to slant up?
Gary, you know,
why does it appear to slant in? You did not give a mathematical equation. You gave a concept, but you didn't give any equations. Why does it appear
with respect to distance is the same as
halfway to that horizon, and another distance farther in the distance it appears even closer? But what's the math for that?
You should
what's
learn
the
math.
Actual equations?
God, why are you asking math, Gary?
I say that the object's angular size is inversely proportional to the distance to that object. That is explicitly defining with mathematics the relationship.
Yes, but in the distance, when you're looking in the distance at the railroad tracks, that far distance is more compressed, and so you don't notice that inverse relationship that you're talking about, right?
That's because of delta. You don't understand delta.
It just looks like a nice
because it changed from 1
to 2, even slant.
Which is a bigger change? It changed from 1 to 2, or it changed from 9,999 to 10,000? Which is a bigger percentage change?
My point is, like the telephone poles, they just look like they're slanting at a nice even pace down, right? When they're all evenly spaced, right? You can draw a line. It'll go from the top of the one pole to the next pole to the next pole to the next pole in a nice straight slant line, right?
Hey, shout out to Larry Scott for $4.99.
Yeah, they're not going to answer.
Says GW.
Hey, I'm going in for dinner. You guys have a nice night.
Good, I was about to boot him. Citation for perspective angles. He was talking to Gary. Thanks for leaving, Gary. Citation for perspective angles in a celestial ephemeris. Follow-up question. What organization publishes the celestial ephemeris? Follow-up formulary for perspective angles. And if you check the YouTube chat, Gary, you'll find the formula if you really want it. Angular size is 2 times the arctangent of half the ratio of the height to the distance. Thank you very much. Jesus, does that guy ever stop talking?
These guys learn their physics.
Go, you go.
No, I was just going to say they learned their physics in art class.
Mm-hmm. But you didn't give a formula. Nah.
I don't know why Gary asks for math formulas when he's math phobic.
Yeah, literally, what is he going to do? What's he going to do with it? Use it?
Are you kidding me?
My request is out there still for anybody, even if Gary doesn't want to do it. If I can get some flat earthers' version of perspective defined in some rigorous mathematical means, I can implement that into a program so I can see what they think 3D looks like. I've never once got a flat earther to give me one.
Well, I had asked Gary that very question. I said, I told him, I said, okay, here's the data. You can work it out yourself. I said, just tell me what I'm doing wrong. So you're saying I'm not using perspective angles or perspective. I go, please give me the formulary or the maps so I may employ it. And he said, hopefully someday somebody will generate them.
Didn't Lemonbird? The closest we got was Lemonbird and smushing, right?
Smushing. I was going to do my Lemonbird smushing and nooshing, but you beat me to it. You have to whine. You have to whine when you have to whine. You have to whine when you say that, though. Smushing and good.
Yeah, and to respond to SE in the chat. Yes, SE, the Earth is not a sphere. The actual model that we use is an ellipsoid, and the ellipsoid does not have a constant radius. The radius is changing. We all know this.
And as a follow-up, the oblateness is slight. So using the sphere is for navigation purposes, just fine. Using it for a sphere for something of only a few hundred square miles, just fine. But when you go transcontinental or you're going on very long GPS, it's all slightly oblate, as measured initially in 1760.
Yeah, the Earth is an oblate spheroid. Therefore, you can't measure angles to build a house, a two-story house.
Well, what he's pitching a shit fit about is the fact that the GPS data, XYZ data, from Lake Pontchartrain clearly shows the change in the radius as you go from the north end of that causeway, 24 miles, to the south end of the causeway. The radius is constantly increasing, which is exactly what happens on an ellipsoid like the Earth.
I'd heard that if the Earth was the size of a pool ball, that would be legal for tournament play.
All that stuff. But SE is trying to make a mountain out of a molehill here. He's bringing into question the fact that the radius of the Earth over that 24 miles changes about 340 feet. Okay, that's what it should do.
And you mean mountain out of a molehill, literally.
On the Earth's ellipsoid, isn't the difference between the two radii about 24 miles?
Something like that.
No. Specifically, that's the difference in the two semi-major axes. Because when you're talking about the radius, you're talking about the radius of curvature. And at the North Pole, the radius of curvature is much longer. It's 3970. Although on the ellipsoid, that's the B semi-major axis, which is shorter. But the center of the curvature of the curvature of the meridian at the pole, that center point is below the center of the Earth.
Oh, okay. Well, as a percentage of the major axis, what is that like? It's far less
3%.
than 3%.
A couple percent. Yeah, 3%. It's something.
Yep. That's pretty small.
It's like the same thing with the orbit. The orbit is slightly again, slightly eccentric, like a 0.016 or 0016, something like that.
Yeah, orbits are elliptical.
Well,
Yeah, I believe.
You could figure out then the size of a cue ball or a billiard ball, and then calculate 3% of that and translate it into millimeters.
You could do that. And the thing is, I've actually seen diagrams where you have like 4 circles, and one of them is the orbit of the Earth and slightly eccentric. And of course, you can't tell the difference between the two.
I believe we have the least eccentric orbit in the solar system. I'm not sure though. But I think that's true.
Yeah, I think you might be right about that. But here's the bottom line to it, SC. If I had shown you those XYZ that data from Pontchartrain, and all 3 of those radii were the same, then you would have reason to call bullshit, because the damn Earth is not a sphere. It is elliptical.
Not a perfect one. Yeah.
And even worse, it's not a
regular. You're making a goddamn fool of yourself. Keep doing that, and I will kick your ass out of here.
And even then, it's not a perfect ellipsoid. It's not a perfect ellipsoid. It's lumpy, right?
Well, we use an ellipsoid model. We use an ellipsoid model, and then we modify it with a geoid model.
Okay.
Yeah, the geoid is orthometric. It does have variation in the vertical called the deflections, the psi eta components. Yeah, those are minor. Those are in arc seconds. They're minor. So the ellipsoid, the WGSA4 ellipsoid, is the mathematical description that's a best fit of the total volume of the planet.
Yep.
It's complicated, and there's no apology for that. But it's only complicated when you're looking at the high detail and high precision. Because if you're on a fucking sailboat or a cruise liner, it doesn't much matter. You can use the Haversine and a 39 60-mile radius, and you're not going to be off, but hardly twice the length of your ship over any great distance. I mean, the scales. They got no concept of the scale of when you're dealing with arc seconds, and then going 800 miles. You're still not going to, completely screw up your navigation. But in geodesy, that shit matters. And it matters a lot. It matters obviously. It jumps right up and bites you in the ass.
Good morning. Does everybody hear me?
Hello.
Yeah.
Okay. Well, I haven't been on Discord in a while, so I've been messing around with my microphone to see if everything works. How's everybody doing?
5x5.
How's the equator treating you? Or near the equator?
Not too bad. Nice morning. We're going to have an eclipse here tonight. I'm going to see if I can go out and film some of it. So.
Yeah. The lunar eclipse, the special variety that flat earthers can never actually comprehend or describe.
It's going to happen here too on the East Coast U.S. You'll be able to see it, but it's like 2 to 5 in the morning, so all the flirts will be asleep.
I gotta check the times again. I think it's going to start here when the moon is still a little bit below the horizon. And I live in Bangkok, which doesn't have the cleanest air, so it'll probably be about 5 degrees above the horizon before you can even see the moon. See what happens.
You'll be able to see it through the lights of Bangkok? Of course, you'll be able to see the moon through the lights of Bangkok.
I think I've heard some flirts ask recently, how can a shadow be red?
Yeah. Yeah.
Atmosphere. That's all I got.
I had a conversation last night where we were having, Ruhif started the question. I carried it on. I guess he had to go somewhere. where we were discussing the intensity or the brightness of the sun being less intense as the sun nears the horizon. And the only question that was asked of them was, why is it getting dimmer? And they would not come up with an answer. They came up, well, actually, they did come up with an answer. They said because it's further away. And then the angular size was mentioned to be the same, so that's not it. And I asked them, what's between you and the sun? And they could not say air. They absolutely, they're just too brain dead to say air is between you and the sun.
They say the same thing about the moon. And in fact, on Nathan's today, or maybe it was Arwen today, claims that the moon never sets. You never see a moon set. And he said you can't show him an example of the moon setting. It simply fades away. So therefore it's a hologram. It's a hologram. That's Arwen's favorite thing.
These people actually ever...
Oh yeah. That's what he says.
These people ever go outdoors and actually make real observations?
No, of course not.
No, that's why you always see their examples are on hallways and desk lamps. They never go out.
Ranty gave Arwen a really and it's not a cheap camera, and Arwen promptly just, I don't know what he did, put it in a box in his cupboard or something, because he's never touched it.
The moon never sets. It sets every day. Oh my God.
You can't show him a picture of the moon setting.
How long do you think it would take me to Google the moon setting pictures?
I did a little bit, and it's really hard because most of the pictures have been taken by artists, and they really want to like up the artistic quality of it, and so they would say CGI right away because it's been manipulated in Photoshop to make the moon shine extra bright and stuff like that to make it pretty.
Right, they'll layer it. They'll take multiple exposures in order to have a better artistic representation. But I do have an animation of one.
I don't know about that one.
Trees in a hill, Blue. Trees in a hill. That's not the horizon. Take that, Glovers.
I don't mean to burst any bubbles, but I'm here.
Hi, Leo.
Oh, damn it. Oh, damn it.
Oh, Rex, leave me alone.
You know I love you. I love Zilales.
Doofus, where's that taken from? It looks like somewhere in the southern hemisphere. Maybe about 10, 20 degrees south of the equator.
That seems what the inclination of that plane is, yeah. I don't know exactly where that was taken at.
Well, I got a video of the same thing from Bangkok, except that the sun is going in the opposite angle, about the same angle.
Yeah, if I had to guess, it'd be like a very northern tip of Australia somewhere, maybe. I don't know.
It looks like the seas, the mares are rotated. I can only see part of them, though.
Here's what I don't understand. People see a time lapse like this. If you're a flat earther, what do you think happens when the moon hits the horizon? Does it just suddenly stop moving? And they can't figure out.
They turn off the hologram projector.
Yeah.
I only came in to mention, welcome back to the Flat Earth debate, Brenda. I haven't seen you around for a while.
Well, past couple weeks, I've been sick. I have not been well.
I'm glad you're feeling better.
Yeah, did you happen to catch FTFE's stream on, was it Saturday?
Oh, fuck me.
Lale?
Which one? I don't know. I watched
Saturday.
Who did you debate?
Jesse
Electric.
Oh, I couldn't stand that guy, so I turned it off.
Oh yeah, well, I mean, I left some timestamps in there in that as a comment in there, me coming in, and kind of a shame because I didn't actually put when Brenda came in. And that was much earlier than I arrived. But yeah, that was quite the night.
They couldn't get off of the stupid intro. He could, if he would have just said, "Okay, the first," if he would have said the first clip is a fake, and then moved on, they would have been moved on. But he couldn't even say that.
Why did you use a cartoon? Huh? A comedy bit. It was a comedy bit, right? It was a comedy
bit.
That was a parody made much, much later, yeah.
In 2000, 2002?
Something like that.
For people who like freedom of speech, they sure don't give globe earthers much freedom to speak.
Yeah. Yeah, no, actually, toward the end there, right after Sin Cleanser got himself removed from that platform for being, Sin Cleanser, anybody who knows.
Yep.
Yeah, the conversation broke down very, very quickly because Jesse / Electric, whatever he wants to call himself, has a penchant for just talking over whatever the answer to the question he asked was. That happens frequently.
Yes, Sin Cleanser really let one go there. That was pretty bad.
It was more than one. I'm surprised that he got the opportunity to let go more than one.
Well, they all do that though. Like today, I was trying to pin down Wissa Gets It on the Michelson Morley, and the fact that they used the speed of light, which Michelson did years before, to use that measurement of the speed of light in the Michelson Morley, and he said that's beside the point. And I said, no, it's not. It is the point. You guys deny the speed of light, but without that measurement of Michelson and Morley wouldn't have happened.
Doesn't he deny atoms too?
Yes.
Yeah, he brought that up too. How many atoms live on the Earth? How can he deny atom?
Yeah. Oh, they tick all the boxes. Come on.
Yeah, he's firmly got his head right in Ken Wheeler's, whatever. So he's disagreeing with the entire concept of an electron too. So that makes the CRT TV a very interesting thing to bring up.
Well, your monitor is LED, so yeah.
Well, these days, yes, but in the old days, it used to be CRT. It used to be electron guns in the back.
Even if Michelson and Morley believed in ether and believed the Earth didn't rotate, they still thought it was a sphere.
They're tiny little robots with little guns, and then they get a little zap, and then they fire their gun.
I'm trying to get Blue to do the Michelson-Morley experiment, but he keeps on talking about like 5 tons of mercury and chickens out.
Can somebody correct me? Wasn't the entire purpose to measure the speed of light coming and going? Like if you're going against the grain of the ether, the speed of there should be a differential.
That's exactly correct.
Yeah. So how are you denying the speed of light and citing Michelson-Morley?
Well, I'm just citing the fact that the Michelson-Morley experiment would have not happened if it weren't for years before, and Michelson determining and measuring the speed of light. So how can you deny that and accept the Michelson-Morley experiment?
Yeah, but measuring the speed of light was the crux of the experiment. You think?
Contradictions are allowed on a flat Earth. That's flat Earth physics 101.
We can't know the speed of light because you can't know the one-way speed.
Well, he tried pinning me down on photons, and I'm like, I never claimed that. I'm just claiming that it was the speed of light was measured. That's all I'm claiming.
The funny thing is, when they make that claim that you can't measure the one-way speed of light, what they're basically doing is invoking Einstein, invoking relativity.
Right.
Yeah. Well, they saw a Veritasium. There's a Veritasium video about it.
Yeah, but so basically they're invoking relativity to disprove relativity, which always cracks me up.
Right. The very notion that you cannot have a measurement for the one-way speed of light is already them accepting the general relative or special relativity is true.
Yeah. All they need is somebody like Veritasium as the another one says gravity is not a force. All they need is some words put in a certain way that they can then sort of twist or well, I don't even know what to say.
I don't understand. I don't understand why they would invoke special relativity when that was 40 years after or more the fact that the speed of light was measured.
Yeah, two-way, which is fine. It's very interesting that they like to use lasers in their experiments. Of course, the laser has got a wavelength, which can't have a wavelength unless that light is moving. So
I'm sorry, but
in all their observations where they fire a laser, they're taking advantage of the speed of light.
You're wrong, doofus. You're wrong because Quantum Eraser has definitively proven that light is a particle. It is not a wave.
Oh God, really?
That's what he says. He also says he claims to have refuted F equals ma.
He refuted F equals ma.
That's
wow.
What he says.
When is he up for the Nobel Prize?
Well, he's got quotes. He's got quotes from a university website.
No, I would let. Okay, where did he cherry pick this?
He's got Feynman's. What he's got. And
Be
Feynman
up
was
for a Nobel
talking
Prize,
about,
wouldn't
yeah, Feynman was not talking about that at all. Feynman was talking about quantum physics.
Yeah, he's getting awarded the Nobel Prize.
Or when they have a Nobel Prize for absolute ignorance.
Well, I gotta head out, but just ask a flat earther, your fellow flat earther, for a logically consistent explanation for how the sun gets behind the surface of the earth every single day.
That's a reification. That's a reification error, and begging the question.
Cheers.
What is a reification error or fallacy?
It's just whenever they feel like it.
No, I'm asking what it is, though. I don't care whether
it's treating an abstract concept as if it was real, as if it was concrete.
So you mean shooting a light beam across my room to measure the distance across my room, is that concrete or is that abstract?
Yeah, I've asked that question before. You can go down to Home Depot and buy yourself a laser measurer and get something pretty damn accurate. And how's that work?
No, I'm just wondering, is that concrete or abstract? Brenda?
I'm sorry, I was sneezing. I'm still not quite over it. I didn't hear you. I'm sorry.
I asked if I go down to Walmart and buy a laser measure and measure the distance across my room, is that concrete or abstract?
Concrete. It lives in the real world.
Yeah. Thank you, Astro Rex. I'm not feeling too well.
What would be?
Well, me and Astro Rex were back on speaking terms. I thought we were like enemies.
When did that happen?
I don't know. I'm just being sarcastic or stupid.
Dude, I don't remember 5 minutes ago.
Oh, you're the plumber, Rex. Okay.
It's one of the joys of getting older. You're freed from any responsibility. You can just say, "Oh, I forgot."
I'd like to know is when a song comes on the radio from your youth, you can sing along the lyrics perfectly. And yet, if somebody asked me, what did you have for breakfast yesterday? I would be confused and would really have to think about it.
Yeah.
The song for my homecoming dance in my high school was "Stairway to Heaven."
Mm.
And every single beginner guitarist could play the first few chords of monets come down out of the sky and they stand there. What was that? What was that name of that again? I forget.
I refused to learn that song and tried learning other songs.
Yeah, but everybody was playing it.
Roundabout.
Yes.
Yeah.
Yes.
By
yes.
the band,
Roundabout.
yes. By the band, yes.
Well, on that happy note, we've been at this for 3 hours now. I'm getting hungry, and I think it's time to say goodnight to the YouTube crowd. You guys can hang out and hear all you want to, but I think I'm going to call it an evening.
Blue, before you leave, I just want to make sure we've made as much head in here as a flat earther has on their model. Is that true?
We've made as much what? Say that again. I didn't understand the question, Lyle.
We've made more sense in here talking to each other than flat earthers have made on their model in the past 12 years or however long it's been.
Well, they've never made any sense. So, yeah. Absolutely.
I want to take some flat earthers, give them a piece of paper and a crayon, and you can't come out until you come up with a map.
Not going to happen, brother.
I know.
Never going to happen.
Well, here's the thing. Why not? Because if the Earth is truly flat, we have done all the heavy lifting already. We know the dimensions of the continents, of the oceans, of the seas. And if the flat Earth was so right, all these pieces should just fall right into place easily. It should just be, you should slap your head and go, oh, damn, obviously. But
they claim that Google Earth is a flat Earth map.
Okay.
No, they really do. They really do. They say that.
There are a few of them that really aren't even that stupid, but some of the more noteworthy ones, like Nathan Oakley and Quantum Eraser, yeah, they definitely.
Yeah, I remember that.
Yeah.
That was a couple of years ago now, because it's zero elevation at the sea in England and it's zero elevation across the Atlantic.
Yeah, there you go.
Yep.
Therefore, it's flat.
But I thought that Nathan Oakley was in the camp that it's a sphere during the day or night and opposite during the day or night, depending on what it is.
Nathan Oakley is in the camp that maybe my video card is on the fritz and I need some more money. That's his camp.
He's probably got a 4090 too.
Well, he needs to in order to stream. What does he stream? That stuff isn't 4K. Does he stream at 4K? I don't think.
Even if he did, you could get away with 4K if you had like a 8 gigs of RAM and a 750 Ti. You don't need.
All right.
In Blue's recent vid, Brian Leakey's quote is extra prescient because he says, of course, the zenith angles exceed 180 degrees because you're basing it on sea level elevations, and that's a spherical datum. And if they didn't add up in excess of 180, then the Earth wouldn't be flat.
I don't know. That hurts. Yeah. That hurts bad.
That was the best I'd heard from Leakey. You know, Leakey said some stupid shit. That one's the best. I put right back at him and said, "Oh, so you're saying the oceans are spherical?"
That statement doesn't make any logical sense.
It's Brian.
I know. It's Brian Leakey. Come on. There was no expectation of logical.
All right. Good night, YouTube. We'll talk to you guys later. Thanks for showing up, everybody. I appreciate it. I'm going to put an end to the stream and go get something to eat. And everybody can keep right on talking. Good night, folks.
Bye. Bye, YouTube. Bye, Paige.